Hey guys, following's an interview with Jenny Nielsen. She's currently the Directing Research Fellow at the Center for Topological Physics in Kansas. And she's got a master's in physics, master's in philosophy. She's a quantum field theorist, and she's working towards, well, or seems to have done the work actually on TUFT, which is a topological unified field theory. So it's a competitor for the likes of Roger Penrose, Eric Weinstein. She has a theory of everything, and I do my level best to sort of try to wrap my head around this. Probably fail miserably. But, we had some technical issues. Jenny's camera didn't work, unfortunately, so it was kind of a bit strange for me not looking at a human face. And there's one or two occasions in the chat where it would have been really useful, I think, to see some hand waving, if not a chalkboard. But, hopefully we can do this again with Jenny's face as well. But she was just so patient and so fun and so widely kind of informed. She sort of had a view on pretty much everything that came up, physics or otherwise. And, I'd love to do this again. I hope you enjoy this content. I'm going to leave it unedited because it was just fun. Like I say, I sort of took my foot off the gas a little bit because of the technical issues and thought, well, let's just relax here and just, enjoy it. So hopefully you will too. Cheers, guys, and thanks, Jenny. This was really good fun. Take care. Bye. So how did you get into physics and philosophy and maths? And are
Oh
you,
my goodness.
is it an even distribution across those three disciplines? And, is one of them more fundamental for you? Any
Physics is more
thoughts?
fun. Oh, sorry, I didn't mean to interrupt you.
No, that's
Uh,
cool.
okay, so physics is more fundamental for me. I became interested in physics when I was about 11 years old when I got Michio Kaku's book, Beyond Einstein, and also his book, I believe it was Parallel Worlds. And I became entranced with the idea of a unified field theory based on those works, but I also felt that string theory seemed needlessly complicated, was my feeling. So basically, I got this idea that I wanted to solve this when I was 11.
Mm.
And I organized my life plan around doing that.
Wow.
So I majored in physics and also philosophy, although I didn't finish philosophy and I did finish physics
So
at
you had opinions on string theory at the age of 11.
yes. Well, it seemed I was frustrated that something that became apparent reading the books was that you couldn't test it now. We would have to
Mm.
test it much later. So like Michio kind of Kaku used this phrase that was like 23rd century physics that fell into the 20th century or something like that. And I was just like, maybe not. But so I became very interested in quantum physics. My mother got me books. I was homeschooled. My mother got me books by Fred Alan Wolf. I was obsessed with black holes and time warps, and she's like, "Well, you need to study quantum too," because she had seen something in Omni about entanglement, and we had discussed that a long, long time before that.
Wow.
So when I saw it again, I was very intrigued.
So
So
that's an amazing sort of badge of honor for homeschooling, isn't
yeah,
it?
yeah, yeah. Especially when you have a mom as intelligent as my mom. She was a musician and kind of a armchair philosopher, but she had very deep thoughts. So we were constantly having philosophical conversations as well. So that was sort
Mm.
of where my philosophical interest came from. And her father was a Baptist minister, but also like a theologian type. So the philosophy kind of came through that tree.
Mm. So
Yeah. And then my
which was the kind of the deeper, where were the deepest questions for you? What was it that really drove your kind of your passion? Was it that field theory you wanted to
I
resolve that?
want yeah, I wanted to solve the UFT
Mm.
because I thought that maybe if we get that, we could do some amazing things, like maybe, I mean, like as an 11-year-old, I dreamed about things like time travel, and I still haven't quite given up on it.
I
And
mean, would
by 15, I was on Jack Sarfati's email list. I also debated a lot with my dad about things. He was an attorney, but law and philosophy have a lot in common as well. And he supported my education and wanted me to learn as much as I could. So, and then Jack, I really was introduced to Jack by Nick Herbert, who I contacted myself because I'd read his book Elemental Mind. And so by around 15, 16, I was on Nick Herbert's email list, which became Jack's email list. And so I was always getting wild, cutting edge and French physics in my mailbox. So that was encouraging as well. I remember feeling very special with this. When I got to college, I realized that like several physicists in my department were also getting emails from Jack Sarfati. He's basically mentoring everyone.
Yeah, but they were probably in their 30s, you know.
Yeah. And pretty wild. And so my influences in physics were predominantly Jack Sarfati at first, and Keith M. Ashman at UMKC, who was a student of like Hawking and Bernard Carr. And so from him, I started working on general relativity pretty early, like around 2006-ish. And so that was where a lot of this stuff started becoming. And he had a very philosophical attitude about physics, even though he probably wouldn't like to say it that way. He wrote After the Science Wars, etc., with Philip Behringer, I think.
What does that mean to have a philosophical approach to physics then? It was one of the questions I'd cooked up was, how has being a philosopher influenced your physics?
Well, it did. It influenced. It gave me a depth and breadth that I felt was lacking before I learned more about the philosophical approach to problems. I studied Châtelet, who translated Newton's work for the popular layman in long time ago, around the same time as Newton and Voltaire and all those people in the salons of Paris. So studying these things and reading the old works and how people reasoned through things and then catching errors and ways that we could have done better, basically it helped me think about how, logic is basically sets and proofs again. So it was just a reintroduction to sets and proofs, but also thinking about each step in depth. You're not just like going through the symbolic logic.
Yeah. So, I mean, I'm a big fan of Tim Maudlin, and he seems to be a sort of like the ideal example of a sort of philosopher physicist in a way. Have you come across his work?
Yeah. Him and David Z. Albert.
Tim,
were very inspiring for me. And
yeah,
so
they're my rock. They're kind of rock and roll for me. Friday night in with a couple of beers and a pizza, and I watch them.
Exactly, they're amazing people.
They really are. Yeah.
And his book on quantum mechanics influenced me as well, Albert's, and convinced me that quantum physics is at least weird if you think about quantum physics from a classical standpoint. It's very odd. So I met a lot of people who kind of went through the Bertelsmann-Sachs method of dismissing quantum. Like when I went to school, people didn't quite believe in quantum mechanics yet, and I was in physics in 2004, so that was odd for me. Like I've been reading all these books and papers, and they're like, well, entanglement is that weird stuff. There's really no application. Then suddenly quantum computing came onto the scene. So then they thought I might have something to think about.
What does for you, Jenny? What does quantum physics say about fundamental nature of reality, or does it say something?
Does it? I believe that it heavily indicates that some aspect of reality is probabilistic, and I have a kind of method for looking at that, but we'll get into that later, maybe. And so it says things are probabilistic. It implies that there are non-local fields at the basis of reality. I think that the wave function is sort of a standing wave picture of a extended wave in that's sort of self-interacting in time in a way that like classical objects do not do, because the wave functions of classical objects there's so many that they cancel. Now there will be people that'll tell you that like decoherence never quite gets rid of the quantum aspect, but I don't really care about that. I mean, I should probably care, but I'll be looking at that later. But basically, decoherence, in my opinion, is basically what creates the classical world. We're still slightly quantum, but basically, if you throw a bunch of different unified waves into one box and you shake them up, the phases are going to clash.
Jenny, Jenny, would it be okay to just give us a 2-minute sort of lesson on decoherence? Just kind of unpack that a little bit, because that seems fairly pivotal in what you're saying here.
Okay, yeah. Well, coherence maybe would be a good place to start. So a quantum object, like electrons or photons, these things are coherent. And what does that mean? Coherence means that you have a field, basically, and the field is aligned in its own phase. So like if you have a single object, it's just one phase usually, so you don't have to worry about it too much. But if you have a number of electrons in a group, their phases might be out of sync. Some of the troughs and the crests might interlock in ways that are destructive. And so that's decoherence. So decoherence is basically how classical objects arise. You have this distributed fuzzy field, but then you put another distributed fuzzy field with it. And like, your electronics, when you get destructive interference and things, like you have two shredded cords beside each other, they start interfering. The fields are the same way because the phases don't align. And then when those phases cancel, you get an object that isn't extended in space anymore. It's just localized. And that's what a particle essentially is it's been decohered by interaction with the environment because there's all these lossy objects around for it to interact with. And some people say, well, that's entanglement, but it's really just interference. So, and I think entanglement is confusing because entanglement usually is something between the two pure quantum states or a mixed state, which means slightly decohered, and another one. So I think just thinking about it is like you put these things around each other in the same box, they're going to collide and then cancel each other out so that all that's left is just this narrow band thing.
Right.
Does that help?
I might have to go over that a few times to just sort of unpack it.
And maybe we can.
But there was one thing. There's one thing that occurred to me though, just sort of from an average philosopher's point of view, right?
Yeah.
This idea of you talked about when things become classical, right?
Yeah.
And there's just something that I remember from John Bell talked about this problem with macro and micro, the macroscopic, and in truth, there shouldn't really be any distinction, because there is no real boundary in nature that separates these two realms. So how? I mean, what does it mean to say that we go from the quantum to the classical? Is that and does that question make any sense?
Really, it's almost like a thermodynamic thing. As you get more stuff interacting with other stuff and bouncing off of each other, the phases interfere, and then you get this kind of extended object that is fairly localized to a certain area because the field gets smaller each time it interferes destructively. So like you can imagine like the field is extended and then it bangs into another field and then the field gets smaller and smaller and smaller until you get this localized object. So really quantum objects are very big and classical objects are small. So the macro world is really quantum mechanics.
So that's almost kind of the opposite of the intuitive thought. It's like, well, isn't quantum about the small? But you're saying that their waves, their
fields
their effects extend.
Yeah, well, as far as we know, to infinity because they're non-local. So so the electron in your brain, because of the extent of the wave function, I mean, and every now and then it might pop in Jupiter and then pop back into your head if it was localized. But it's really not that. It's really, I mean, if you go to measure it, but which is its own can of worms. Like, why does measuring?
What do you mean by measurement?
Right, and what do you mean by measurement? So we can get into that. But the key here is that quantum objects are expansive, big, beautiful things but they're fields. And it's much easier to measure them roughly where we think they sort of are. because they aren't, like the density is still localized of these things because, and that's an interesting thing to think about, like why is the density localized at a certain location? It's partly because things are decohering a little bit all around from the beginning, but I need to think about that a little bit more. So particles are,
Jenny, what do you think is fundamentally sort of what is the substrate for all of this? And this might be a kind of like a nod towards metaphysics here. And could you easily put yourself in a sort of physicalist or idealist or panpsychist kind of position, or is it not that simple?
It's not that simple for me. I often like when I'm Roman Catholic, so obviously I believe in all these metaphysical things at some level, But, and I'm also Zen Buddhist, so, I have a lot of Eastern philosophy influence. I like the Upanishads, things like that. But I don't think that mysticism and physics is the same thing. There's a really beautiful book called Quantum Questions about mystical explorations of some of the world's philosophers. There's another one called Quantum Profiles that gets into it a little bit too. I don't remember the authors, but I think that those kinds of thoughts are good for you expanding your mind. Like how many angels can dance on the end of a pin seems like a stupid question, but thinking about these things is actually sort of the medieval way of contemplating the same sorts of questions. Like they talked about whether the soul could be represented in a number. And that's sort of the question of like, could you upload your mind to a computer in bits? It's the same question, but it was the medieval version. And people were, killing each other over these questions, literally in the Middle Ages. But where am I going with this? Well, I think that the substrate, I'm really fond of fields. I really approach physics from a logical positivist standpoint, in that I only think that we can talk in physics about what we can measure, which is kind of a boring. It's kind of a boring.
So for you, in some way, physics can't give us metaphysical insights then.
Right. I mean, here's why. Because everything that we do in physics is we take a measurement of something, which means you're comparing something to your ruler, and then that's just a ratio. And so you're just getting these ratios of one measured property to another and seeing how they relate, and you really don't know much about what they are. Like what's charge, what's mass, why does mass have a certain feeling like as weight, which is multiplied by mass, the force of gravity. And so so why so the question is like, what are we really talking about when we talk about charge? Like these things are just things that we put in a measurement box and we look at them and we try to measure some kind of extent somehow. So like we're just relating one measured property to another measured property, and the properties are properties of something feasibly maybe, but what we're really working with is constantly relata. And so I think that physics is really kind of like explanation in science more broadly is sort of a relational structuralism where we're comparing measurements of measured things to one another. And I'm not saying that like Jane Goodall watching the chimps isn't science, but she's still thinking about like, well, when the chimps eat food, they behave a certain way. That's relating one variable to another variable in some degree. In psychology, sort of the same thing.
So physics is about the observable world, right?
Yeah,
and we know we just know that animals and even different humans experience the world differently and so on. So there's a kind of this phenomenological aspect of physics. So, but then again, there are these regularities, aren't there, within that?
Yeah, there are regularities
and testable and repeatable, and Einstein stuff is kind of provable.
Yeah. You can kind of deduce qualities from the quantity at some level. Math has qualities to it. So I'm kind of talking rather nihilistically, that saying like, well, it's just measured properties, but you can deduce things about the qualities from those properties, and math has a certain kind of property to it. So, which is why you can look at a mathematical equation and say to yourself, well, this applies to this system because it kind of looks like it, at least in terms of the changing of the rates or the geometry or whatever.
Yeah. But why do we have math though? What's your view on math?
What do I do?
Is it something, is it discovered or invented? I mean, are you a Platonist? What's your position on math?
It's discovered.
Okay. So it's there, whether we exist, whether humans exist.
Yeah, these relations of properties exist in ratios, regardless of whether we measure them or not. So I believe that. I do think that mathematics, as we use it, is a descriptor for that relationship. I don't think it's like, I sort of take a nominalist view in the sense that I think that math, we're relating symbol codes for the thing that it is, and I'm agnostic to what it is, but we're measuring those things. And so I believe there is a substrate of some sort. I don't believe that everything is just relations all the way down. I think there is something, but I don't think that physics directly tackles it. And maybe experience does tackle it in a way that physics doesn't. I mean,
the thing is, who else can we turn to when it comes to questions? So take things like sort of Zeno's paradox, right?
Yeah.
It seems to be, it's about space, and space is what we experience, and space is what this study. So who else can we go to for answers about this stuff?
Well, Xeno, you can go to calculus to get some kind of superficial resolution.
Okay. Could you explain that for us then? Because some people don't think there is a resolution to it.
There isn't exactly a resolution, but you can approximate, like, it's basically dividing infinity by infinity. Like you can say like this object contains an infinite number of infinitely small things, and then you divide infinity by infinity, and you get that's the layman's version of what calculus is doing. Really.
What's infinity divided? Is infinity divided by zero?
It's an infinite number. Well, it's an infinite number of infinitely small things. So then like Yeah.
Hang on.
So you kind
Well,
of show that's literally basically
head
what calculus is
exploding.
doing. So it's like, well, because, and then you multiply it by some, constant, and then you get to what, one times the constant. So that's kind of really what calculus is doing. So an infinite number of infinitely small things is finite, and people will yell at me and say that's bullshit way of talking. But as far as I can tell, that's sort of like that's what
I'm
we're
not
doing
going
with
to yell at you there. I mean, this is way above my pay grade. I'm telling you.
Well, it's fine.
I hope you don't mind. I'm just bear with me one sec. I'm just going to get myself a glass of wine, if that's okay.
Okay, I'm going to get some caffeine. I'll be right back too.
Yes, Gabby. Oh man, it's fantastic.
Yeah, this has been lots of fun already. So.
Oh God, yeah.
Yeah.
Oh, we've got to. Yeah, we've got to get that camera sorted at some point. But this is fun anyway. I mean, honestly, everything that could have gone wrong this end has gone wrong. So I've got lighting issues. The sound went funny. So I've got this dodgy microphone. It's hilarious.
Yeah, I had all that. What I really need to do is I need to use my other computer, and I think that would help a lot.
we can do this next weekend or during the week, anytime you like. But this is fun anyway. And if it's okay with you, might just stick this up anyway.
Oh, that might be fun. Yeah, maybe we could just do a reboot and talk about more things.
It's funny. I'm not quite sure where to look. I've been sort of like gazing at your little profile picture, and I think that's kind of like I end up kind of hypnotizing myself. So I just. It's a good new experience for
Zoom is such a strange seance like thing.
But
are you here? Let us know.
I wonder what you are. There's part of my brain that's kind of like expecting to see you move, and like I wonder what she is doing. What do you look like?
Well, we're really frog brains. Part of our visual system doesn't actualize until we see motion, right?
Yeah. But I'm sure I'm trying to fill in the gaps somehow. So we do, don't we? But I was going to ask you because I did do as much reading as I could. Well, which was a struggle in places, to be honest, when you're talking about the sort of SU groups and all this. But topological, right? So topological physics, that presumably you're accounting for things as though there is this kind of foliating structure.
Yeah, that's correct.
To there being sort of objects kind of related to each other in a presupposed sort of manifold. I don't know. Yeah. So I want to get underneath. I want to get underneath what you're actually saying here. It sounds amazing.
One tip is I really like Adobe Summarizer. So if you take that, and unfortunately it costs like $4.99 or something to use it consistently, but if you put my paper through that, it'll summarize things in a very simple level. And it's not perfect, but it might be helpful for people. And I've used other AIs to try to do like explain this to a third grader or whatever, but that one does the best job, I guess.
Yeah.
And then I've put up some of my own writing trying to explain it. So the world's basically a yarn ball. But the yarn ball is wrapped around a little ping pong ball. And within the ping pong ball, there is another yarn ball wrapped around another smaller ping pong ball. And in my system, you start, well, really with S3, although there's an S1, which is just this, the S1 is just a circle. And then each of these yarn strings are circles, but you can also model them as a spiral and it works just fine. And then it's just one yarn ball. One string of yarn wrapped around the whole thing. Which I don't know if this helps, but basically you can think of the timeline of the universe or the timeline of a particle. Like you can view the particles as this little string, or you can view the whole universe as one field, and then you can see the timeline as a spiral. And the loops indicate that the universe is like breathing. It's not just expanding forever, and then you have heat death, which is really cold death, the cold death of the universe. So I favor Robert Frost's. Some say the world ends in fire, and some say in ice. But from what I can know of desire, I hold with those who favor fire. I was kind of a fire, but it's fire, and then it's cold, and then it's fire, and then it's ice.
How does yours end, Jenny? Yours is fire.
There's no end. It's just fire.
There's just no end.
There's no end. So it's fire, then ice, fire, then ice, fire, then ice.
I like that.
And I think Penrose, ascribes to something similar. In fact, I think my view is sort of analogous to his view of the cyclic universe.
You mentioned Penrose and his twistor theory as one of the attempts at unification, don't you? And
it was my favorite actually, because it uses fiber bundles, which is the same essential structure, but I use the complex Hopf fibration. The classic version, he uses another fibration between, oh my goodness, it has CP3 in it, or CP2. I'm trying to remember the exact mathematical formula.
Jenny, it's probably worth saying that like probably half my viewers are much smarter than me, right? So don't worry about me not understanding it.
Okay, well,
right, because
the twistor theory, I don't remember the exact structure off the top of my head, which I wish I did because I've looked at it a lot. So why don't I? But it's a different bundle than the one I use. So different things fit on it. It works really well for things like spinors and things like that, and talking about them. You can use twistor theory to look at those things.
Could we briefly talk about what those are? If we could we put it in a sort of, philosopher-friendly frame of reference? What are these spinors? And
oh my gosh, spinors. They're kind of like a precursor to thinking about particles altogether. They're just like they have spin, and okay. So spinors, that quantum objects have, like, some of them have spin 1/2, right? Like electrons. So spinors are mathematical objects that represent fundamental particles with spin 1/2, like electrons. Does that sort of help a little? And so you can represent them as these sort of Mobius strip type objects, where you're trying to determine like where spin 1/2 comes from. And so in my theory, the spin 1/2 comes from like the structure of the fibers, which are twisted. And so it's similar to the spinor concept, but I don't really think about spinors very much in my work.
So you use the term bundle, don't you? And so what is that bundle? What does that bundle contain?
It's the yarn ball. It's a yarn ball, and the yarn makes a manifold, but it's not just a manifold because each of the fibers which make up the manifold are twisted. And so it has properties that a regular manifold do not have. So even though we talk about S9 or S7 or S5, and so my thing is stacked. So you have S1, then you have S3, then you have S5, then you have S7, then you have S9. These are just different dimensional sphere manifolds. So if you start on S3 is basically, and we call it S3, but it's kind of the 4-sphere in a way, because S3 is the 3D surface of the 4-sphere, if that makes sense. So it's a 4-dimensional object that we're viewing 3-dimensionally, which is kind of hard to think about.
How many dimensions are there in your model?
Oh, it's infinite, but I mean, it could be infinite if you want it to be infinite, but I end at S9 because that's sort of where known physics ends, and I don't want to get too out there. I might look at S11 in a little while after I'm happy with S9. In fact, there may be forces at S11, but I don't need them right now because most of physics is on what we've got here, and I don't think we're going to get to S11 for a long time. Then we're getting into string theory type math that isn't immediately testable. So I verified. What I do is I look at what a field flow over. Well, the whole thing is kind of a field, but if you look at a vector dynamic field over that static field, you would use something called a Beltrami flow. And so when I put the Beltrami flow over the Hopf fibration, which I don't even have to put there because it's naturally what a flow over this thing looks like. So it's like you have an object and then you run water over it, and then what does it do? And the water running over it is basically just interference patterns.
The what, sorry?
The water is basically field variations because it's a noisy field. It's not a perfect field. And so it's always interfering with itself a little bit. And so then that causes flows to happen. And the reason it's always interfering with itself a little bit is the twist, because the twist pushes, for lack of a better term, like the current, it's not really a current, but it pushes the path of particles, the path of the field into this, and I wish you could see me here, like I'm twisting my arm. I
can almost imagine it.
yeah. So I'm kind of circling my arm and showing a twisty, almost Mobius. Yes. But
I'm just briefly, can I just interject, Jenny? So are we saying that these dynamics are happening and this is the ground level of physical reality that we can observe, right? So this is what's underneath particle. So this should be able to give us an account of electromagnetism. It should be able to give an account of relativity, presumably.
Yeah.
So is that what this is all about? Is it about unifying all of these different bits of physics and making it all
right and calling it one? So the unified field means you have one field, and so and what's interesting is that you don't usually when people are trying to do this, they sort of, not everyone, but a lot of times what they do is they take fields, and then they put them on a metric, which is just sort of like a sheet that they're putting everything on. But in my view, in my world, there's no sheet that I'm plunking it on. The sheet emerges on the bundle.
Right. So space emerges from your model. It's not. So you
Yeah.
don't. Right. Okay. That's okay. That reminds me of Wolfram. I mean, he says he does the same thing with his Rulliad, and also he says
Yeah. And
he also says that I don't know whether his mathematician friend Jonathan agrees, but he also says that he can unify quantum field theory with relativity, doesn't he? And
yeah, I think
he
he does
thinks he can
claim that.
explain thermodynamics as well.
Yes, it's interesting because like maybe his view is complementary. I've always been interested in his view. Like there's this idea you can get complex behavior out of just a few simple rules, right? And that's kind of where he's coming from. I have his book, A New Kind of Science, somewhere.
Yeah, me too. It's a cool book, man. It's a cool book.
It's a very cool book. I'm not sure that it's very effective for representing fields, but I think that it can give you a different view, of the same material. Like I don't, even though I think that I have a TOE of some sort, I don't think that the theory of everything is literally everything. I think there always are going to be undiscovered avenues of looking at things. But I do think that, and I can't evaluate Wolfram's theory because he's very advanced in what he does as well, and he comes at it as a totally different angle than I do. But what I do is I tried to find a field representation that could accommodate all these different things, and I looked to topology because, well,
why did you look to? I mean, Jenny, do you mind if I smoke? Is that okay?
Oh, I don't mind if you smoke at all. That's perfectly fine.
Okay.
I've spent a lot of time leaning against walls talking to physicists who are smoking. I learned a lot of things that you couldn't learn in class. So yeah, it's totally fine.
Thanks, Jenny.
Also, I'm not
sorry. So go on. So how did you? So what? Why topology? Why topological physics? What was it about that system?
It's kind of, it's complicated because like part of it is that essentially the metric space of general relativity is a topology. It's a manifold. So you're immediately getting into topology when you work with tensor manifold and quantum and general relativity. But really, and this is going to be sounding crazy, like kind of mystical, but I was at UARC and I was working with laser modes and things like that at working with Rita Valles there. And I was deriving all these, what are the Laguerre-Gaussian beam modes, the Hermite beam modes, and there's a word for the master equation of all that, but I'm not gonna get into that. But when I was working on that, I was also, as usual, drinking a lot of caffeine, and then I got sick with allergies because the mold count was very high, and my grandma applied me, because my grandma lives really near there, so I ended up spending a lot of time at her house, my grandparents' house, and she applied me with a Stelson cough syrup, and then I was thinking about the wave function of the universe and what it would look like. I'd been thinking about
as one does,
Yeah, as one does. You just think about it. And also I concluded to myself that it had to be outside of time. And I don't remember exactly what. Yeah, I think it was because of Wheeler DeWitt and other things led me to this conclusion, and also the fact that there's entanglement in time, and there's this test of multi-simultaneity, which is basically a test, really, of whether this is a Geisen Suarez paper, and there's other names on there, but for some reason I always remember Geisen Suarez. So they test whether quantum entanglement persists when you put objects in different reference frames. So here we're getting into relativistic quantum mechanics. People thought that when you put these things in different reference frames, because they're effectively in different times, that the entanglement would disappear. But what they found instead was that it maintained, and you could still align them, like comparing the two reference frames, which was really, really kind of out there, and kind of gives you a question of like, is there a quantum clock? Is there a master quantum clock?
Yeah.
So I was looking at that, and then that sort of indicates that all times are one at some level. And then you also have to remember that in general relativity, a lot of things that we say are weird about quantum are also weird in general relativity. In general relativity, because the speed of light is constant, you can look at depending on how fast objects are going. Well, not really how fast they're going, how fast they're accelerating, which is the wrong way of saying that. But depending on how they're accelerating relative to one another, and because of the constant speed of light, like when you shine light from a flashlight, even if you're going at 100 miles an hour or whatever, it's the same. It goes the same speed. It doesn't add up, which is weird. But we can show this is true.
Yeah.
Because of that, for some reason, it's weird to think about, and I don't know how to explain it, like why this is, but the direction of causality can change depending on, like, I throw the ball in this
Retrocausality,
reference
wow.
frame. Yeah. So I throw the ball to my friend in this reference frame. He catches it after I throw it. In the other reference frame, I catch it. Like I throw it at that's the first thing that I threw it. I mean, excuse me. The first thing is that he catches it, and then it goes back. It's weird. Does that make so causality basically can flip?
How
So
does how does causality work in your system? Is that just
it's sort of causality. It's introduced roughly by the torsion of the object, which just means the twist represented as a motion around the. So you have this torsion of an interference, and this pushes it around the ball, and they're all at a certain angle, so things are just kind of forced to travel a certain way. And I wish you could see my motion because it would explain a little bit better. So causality is sort of introduced by the arrow of time, which is, my opinion, is introduced by the chirality, which just means the directionality of that twist.
Yeah. Can I just briefly ask something, probably a very daft question? This idea, so is physics necessarily reductionist? So is it the case that you guys are looking for small things that govern the behavior of large things?
I don't think so.
Can there be top-down causation? I think.
Yeah, there can be, I believe.
Right.
Yeah.
Okay.
I think George Ellis is pretty much.
So in a way, that's the free will question as well, isn't it?
Yeah, yes and no. I think that free will is somewhat metaphysical and getting into like how you think about things. So, for example, if I'm like, and I don't believe the universe is perfectly deterministic, but even if it is, so I'm sitting here and I'm a little piece of the universe, right? So when I make a decision to do something, I feel this sort of ownership of that decision. So that's me as far as I'm concerned. But maybe it's the universe making that decision, and I just happen to identify with this little chunk, but really it's the whole thing. So so there are ways of reconciling free will even if you believe in determinism, which I don't, because I think that there's a probabilistic element to quantum mechanics, and I also believe that I don't even believe it, I just know from the math and looking at chaos theory that there are certain classical systems which amplify quantum effects. I believe the brain is one. So that having been said, probabilistic behavior, you're asked Sabina Hausenfelder, you've probably talked to her, but you should if you haven't. She doesn't believe in free will. So she would say, and this is perfectly reasonable, random things are random. So where's the free will in that? You could even say that free will is determinist because I'm determining my action. I'm not when I decide whether I'm going to cross the room or if I'm going to use the restroom or this isn't some random thing that I decide to do, right? It's something that, yeah. But I think that there's a certain element of the brain where you have different fields interacting with other fields. And I don't know where the will would come from, but somehow I identify with this mix of fields, and the way the fields mix influences what kind of measurement you get or what kind of output you get. So there's some weird combination between probabilistic effects and determined effects in the brain. So at least that's how I see it. But why am I that, and why do I feel like that's my will? I mean, that's an open question.
There's so much going on that's kind of affecting my present sort of status, that's completely beyond my control. Notwithstanding all the stuff, my place of birth, all these accidents about my demographics, the whole thing is.
Right, and
I'm
the
very
way
much
we bond with people even is so I like the color blue, they like the color, all these random things about us, and somehow out of the coincidences of these random things we're there's a connection here, and it's so maybe meaning is somewhat in the chaos, not just in the order like we like to think.
Yeah, I mean, when you talk to biologists, neuroscientists, most of them kind of deny that identity is a real thing. Really, it's a sort of it's a convenient fiction. It's something that gets you out of bed in the morning.
Yeah, it's often, because
and that's quite spooky. That's kind of spooky, isn't it, for most people to hear that? But
yeah, and the way I think about the identity thing might be a little different than say Daniel Dennett or a philosopher of biology might look at it. Life is an open system, so like I'm constantly taking in elements of the world around me. I'm getting light from the
Mm,
world around me. My skin is permeable. I'm constantly taking in germs and stuff.
mm,
So like,
mm,
and I think that openness has something to do with how we sense things. I mean, obviously, like we're taking in
mm.
waves. We
Yeah.
vibrate, then we process this vibration somehow, either by the eardrum or by the eye. And I believe the eye actually can absorb photon by photon, which means the eye is a quantum system at some level, which is kind of interesting. So yeah.
So do you believe, are you a physicalist then? So do you believe that photons are actually out there, whether we're looking at them or not?
Well, that's more of a realist versus of a kind, I guess, versus a physicalist. I'm a
Mm,
physicalist in the sense that I think that uh, when I'm practicing science, I'm measuring physical things.
mm,
But at the same time, like physicalism is often like I'm more towards positivism, even though I do believe there's a metaphysical reality. I just think you can't talk about it scientifically
mm,
always. Sometimes you have to bring in like qualia, and then you're talking about sensory data and
mm.
perception and things that we don't really know how to talk about at least quantitatively, at least now. Like I can talk about like the paths my neurons are taking, like how my neurons are spiking quantitatively, but can I talk about like the feeling I get when I have there's caffeine, it's speeding me up, but I get a perk out of it, and that perk can't perfectly be represented mathematically, can it? I mean,
Mm.
that's the question.
Yeah, I mean, I suppose the question is, should physics be able to account for consciousness and
I think maybe
qualia?
to some I think that we can account for correlates of consciousness at a level deeper than you might get from just a pure biochemical view. For
Mm,
example, like when you look at even like things like epilepsy, you're looking at patterns of waves. That's what they're reading when
mm,
they're reading brain waves, which are associated ultimately with fields.
mm,
And so in epilepsy, like you get these highly ordered states. And then your brain tries to prevent those highly ordered states by things like a migraine, which split up different parts of the brain and isolate the sort of point of order that's too ordered because it's like it's just taking on sort of a certain voltage or whatever. I'm not a total expert, but I know this that like these states they
mm.
go from chaos attractors to a more orderly, constant rate, and that's you can if it maintains, you get status epilepticus, which means you're like frozen in a seizure. But so where am I going with this? Well, this is physics. It's not straightforward biochemistry anymore.
Yeah.
So you need to introduce chaos theory, and you also need to introduce field states to understand the brain. And so that's kind of part of why I'm saying mind is probably at some level a field too. But
Mm,
this gets kind of metaphysically interesting because since in a lot of views of fields, but especially in TUFT, topological unified field, um, such an arrogant name.
this is your theory of everything.
Yeah.
Yeah.
Well, I get the particle masses off of this thing, which is intriguing because no one's ever really done that, predicted from first principles. You see some people who have tried to do it, like sort of phenomenologically, like just guessing at things, but you don't see like a prediction from first principles of the particle masses. You see like string theory kind of hand waving at like mass hierarchies and things like that, but you don't see exact mass values. So
Mm.
exact mass values, as far as I know, were I had the first ones. My April 20, no, March 22, 2025, I came up with an equation that leads to the mass hierarchy. So as far as I know, I'm first. Um, there's someone who has one on April 4 or April 5, but it doesn't make sense unless they were taking it from my paper.
Mm. I mean,
But
isn't that sort of Nobel Prize winning territory? If you've got a
yeah.
unified
Well,
field, it kind of is, isn't it?
yeah, I found so when the neutrino masses are measured and when they have a wobble of light that match my wobble, that's quite a big possibility that I could get a Nobel. I think it will match because everything else matches. So the probability from a Bayesian pi like is like 9999,
Mm. So
which
there's
is
a strong Bayesian probability that you're going to win the Nobel Prize.
yeah, I mean there is, but probably like 10 years from now or something because they're very slow.
Well, I mean that's just unbelievable. And
It's very strange. It's very unbelievable for me because I'm this dirt poor girl who grew up in the prairie.
but I mean
You have a $2 million, whatever the prize is now. It's like, whoa, I can't even imagine.
this is genius level stuff, Jenny, isn't it? Come on. I
Oh,
mean,
well,
you must be extremely proud of yourself. I bet your folks are, man.
yeah, my dad is very proud. My mom was very proud when she was alive, but I lost her to cancer a couple of years,
I'm so
3 years ago
sorry.
now.
I'm so
Oh,
sorry.
it's all right. I mean, it's terrible. It's horrible. It's world bending, but I'm okay.
Mm.
And maybe she's okay at some level. I don't know. Because if time is all one, we're all still going, right? And also, if we're just these random arrangements of molecules, and if we're in an infinite universe with infinite time, eventually we're going to repeat, right? It's the same.
Yeah.
Just,
Yeah,
yeah.
absolutely. That has to be the case. That's necessary, isn't it? Yeah.
Right, which is weird to think
Yeah.
about. So
So
if
and
I'm
then
just that arrangement of molecules, I'm going to exist again. So I'm not going to worry about it right now. And I won't.
mm,
And if I'm not there when I'm not there, then I won't perceive any like cutoff because
mm,
I'll just be, I'll wake up in a different room somewhere, or maybe the same room if
I think
Nietzsche is right.
you touched
So
on this a little bit earlier. You said, "Am I the whole thing, or am I, you know,
yeah,
a distinct?" I
and
think that
yeah, and like, what if there's a, like, you've seen the single electron theory by John Wheeler, I think.
yeah, kind of.
Basically, the idea that it's just one electron zipping around, and
Yeah,
I don't know
yeah,
what
yeah.
the
Just
molecular
got filling
orbital.
out all the detail, painting the whole cosmos. Yeah.
Yeah, zipping back and forth in time,
Mm.
and and I'm very fond of Ruth Kastner's transcausal interpretation of quantum mechanics, and she keeps saying that like I should use hers. I think that I'm roughly using the same version, except that I don't talk about a handshake, and I call it
So, what's
transcausal.
the
It's
handshake? Could
not
you
really the
talk about the
transcausal; it's
handshake?
the trans. Oh my goodness, what is it? Transactional interpretation of quantum mechanics. So I'm like transcausal interpretation is transactional. It's kind of the same, but I don't think about it in terms of signals going back and forth because to me that violates relativity. But that's what she was working with because John Kramer came up with that idea, and it kind of made sense in the
Mm. So,
back in
so,
the 80s
so
or
you
whenever.
say it violates relativity. So there are certain kind
Mm.
of principles within physics that you want to adhere to that you won't.
Well, the problem is that like if you go faster than light, you start going backward in time. So
Mm,
you're not really going faster, you're just going backward. So
mm,
that kind of causes some problem. Like, and it's because going faster than light introduces paradoxes. But if you were always traveling faster than light, which presumably maybe some things could be, and when we know because we'd just be looking at their backwards
mm,
trajectories and we wouldn't
mm,
necessarily see them that way. Like it would just look like a forward trajectory that was kind of weird, right?
mm. That reminds me of was it Philip K. Dick, Counterclock World? I don't know if you come across that
Mm,
science
I
fiction.
love PKD. He's
Yeah,
amazing.
he is pretty awesome, isn't he?
Yes, yeah,
Well,
the way he thinks about things.
yeah, Blade. I mean, he wrote Blade Runner, didn't he? Do
Yeah,
robots
it was
have
called
electric?
"Do Robots Dream of Electric Sheep" or
Yeah,
something like
yeah,
that.
yeah.
Yeah,
Not
or
many
"Do
people know
Robots
that.
Count Electric Sheep or Dream of?" I don't remember which one, but
Mm,
it's a good book, and it's basically the same plot as Blade Runner, just modified a little bit. Well,
mm.
out of the movie, is it modified a little bit? But yeah, um,
So
yeah.
yeah, yeah. Carry on. So carry on where you were. I was just going to ask you what you thought about consciousness and just a
Oh,
straight question.
I
What?
think I think, well, even though I talk like a logical positivist and all this crap, I
Yeah,
think,
yeah.
yeah, that's my physical view. From a philosophical point of view, I think that consciousness is probably a property of certain organized fields, which is weird because like then then you get panpsychist, right? Like electrons have they feel a blip when you bump into them or
So do
whatever.
you think it's still emergent then? It just emerges when we get those appropriate field structures.
Well, I think that, well, but the fields always existed, right? So I think that the fields might, in and of themselves, hold some kind of proto sentience, which sounds
Right.
totally insane. But if you think about it, if you
No, it
even come
doesn't.
at it from the materialist view, like, oh, I'm my brain states, that's what I am.
Mm.
That's the same thing as saying
Yeah.
mind is the brains.
Yeah.
Like panpsychism and hard materialism are the same thing from a different
Mm.
angle, which
Yeah,
is
I
weird.
think materialism's kind of crazy. I think to sort
Oh,
of,
it's very crazy.
I
It's
mean,
just as crazy.
that's more mystical these days than the other interpretations. One sec, sorry.
Oh
Um,
yeah. They're very logical positivism is completely like via negativa, the negative way of achieving enlightenment or whatever. It's
are you
totally
talking?
just
You're talking A.J. Ayer and Wittgenstein and all these guys,
yes.
yeah?
Oh
Yeah,
yeah,
yeah.
yeah,
So, so basically, a statement has to have logical coherence or some empirically verifiable
right,
content, or it means nothing, right?
right. I guess so, but
Is that?
here's another thing that I get really obsessed about is that when we talk to one another, we're not really conveying thought. We're conveying a code that we're
Noises.
yeah, well, semiotics, like you have the thing, and then the arrow points at the thing, and that's the symbol or the word or whatever. And I think
Yeah.
semiotics has a deeper view than semantics, which is more like grammar. So semiotics is really important when you want to talk about meaning. Where was I
Mm,
going with this? So
no,
when we
carry
talk,
on.
we're converting a state to a code. And what is the state that we're conveying? It's a state of mind, right? A state of consciousness, a representation, some people say in the brain, but I don't think it's quite a
Mm,
representation. Yeah. So, um, but I think representation might be a red herring. There might be a state in your mind of some sort, some kind that is happiness or is joy or is this kind of joy that you're experiencing right now that maybe nobody else experiences quite like that. But we know roughly that approximately it's joy or whatever. But so we have the word joy so that we can talk to one another about that state. But the state isn't the code. It's something that the code represents, something that we associate or correlate with it. And so a lot of times when people are talking about the brain, we're talking about like computation, which is sort of about what you can do with codes. But I think the deeper part of the brain would be states. And what has states in physics? Well, quantum coherent systems have states. So I think that and there's no other mathematical analogy that I can find for a state that you can kind of translate to a code. So I think that Penrose and Hameroff and those guys are on the right track. I don't necessarily jive with everything that they're doing. But the idea that there's these quantum states in the brain, maybe at the level of microtubules, maybe somewhere else, maybe at a lot of like ion channels, EM waveguides, and then there's Froelich condensation, which my colleague Jack Sarfati works with, and so we recently came out with a paper. I put it up today.
Yeah, I love how Stuart says he talks about the microtubules and he says people far underestimate the processing power of the brain because every single neuron has its own sort of data processing structure. These, it's like times a million or something, isn't it?
It's
and but this is fascinating because so we're saying here that it is possible for physics to kind of say something about consciousness, right?
There's something.
So you think it is, right? Okay.
Yeah, I think that we are saying something about consciousness here. I think that the thing that we're encoding when we talk is a state. And I think that when you talk about a state, now there are other things, now there would be mathematicians say, well, can be a state, it's just like an arrangement or whatever. But that's not quite the same kind of state I'm talking about. I'm talking about something that like can't be encoded, really. You can create and correlate with it, but it's not the same thing as the representation. And the thing that has that property are fields, which are coherent fields specifically. They have state, and the state isn't accessible. You can only just like poke at it and get some kind of measurement, which then you can encode, if that makes sense.
Yeah,
but,
kind of.
Yeah, and some of this is like sort of knee-jerk intuition, but I think that there's a way to say this more formally.
So was there anything?
I haven't started my theory of consciousness
just briefly, was there anything sort of purposive going on before the emergence of complex brains and minds, that we can recognize?
In the sense that there was a master evolutionary state of the universe that then splits up into particles because the thing is noisy, and so like it interferes with itself and it starts generating stuff.
Wow.
So in that sense, like there's something purposive in the sense that like, well, we have this chaotic, noisy thing that's also on top of this very ordered thing, and it necessarily generates these particles and these beautiful things. So there's that purposive is like in the sense of maybe teleology, like you have an end to it, and it's this complicated, complex, beautiful world. So yeah, maybe that's there from the beginning. From the math that you're going to get particles, which is really crazy.
So those particles, so the behavior of the particles emerges from your foundation.
Yeah. And
oh my God!
It's crazy. It's totally
I mean,
I found all I suspected because I talked about the cough syrup. I don't think I ever finished that story. So I see this big ball of entangled world lines, which are also field lines, and it was branching because it's not just one. It's a hyper version of the bundle, which is kind of hard to explain, but. And so that's kind of what I saw in my head was this thing. I was like, what is that thing? That thing is what the field looks like. And I'd never seen anything mathematically represented quite like that. And then a couple of years later, I was on the internet and I came across the Hopf vibration. I was like, oh, there it is. That's what it looks like. And I noticed that other people were talking about it as a metaphor for fields and as a metaphor for the Schrodinger bundle occasionally, and like other things.
So you arrived at this independently and then discovered this.
Oh yeah, totally independently, just based on a crazy.
I love that. There's something so gratifying about that, isn't there?
Yeah, and then I discovered to my amazement and joy that Penrose, my idol at the time, and still is, Roger Penrose, he had determined that bundles were the thing. He used a different bundle than I found fascinating, but it was the same basic structure of the Hopf bundle. So he uses a different Hopf vibration. Like there are different ways of representing the Hopf vibration by wrapping fibers around different sorts of shapes and objects. As it turns out, my object is the only one that will hold the gauge fields, all of them simultaneously with gravity, like just because of the shape.
So hang on, so that's SU and SU1, SU2, 3, yeah?
Yeah. U1 being EM, SU2 being weak force, and SU5 and SU3
strong nuclear, weak nuclear.
Yeah. So, and they are analogous to different bundles, and like we write them as a product space because it's just easier to think of like these things as like they're sitting together and interacting, and the product space is a little different than what we think of as multiplication, but it's similar enough that you can use that as an analogy. But the problem is when you plug a bunch of manifolds into a product space, you lose something, which is called the twist. The twist of the bundle of the fibers is lost. It becomes just like spaghetti straight if you put them in a product space. But we know from a Aharonoff-Bohm effect and some other things, but especially a Aharonoff-Bohm and also charge quantization and things like that, that it has to be twisted. So that means that the product space is sort of a digression from what we really need, which is topology. And topology is sort of a kind of geometry. It's the study of basically manifolds and twisted big things that you can deform in certain ways, but they keep their shape sort of like Teflon. So like they keep their structure. So like there's this joke that like a donut is the same as a coffee mug because there's a hole, and then there's this structure. But it's not quite the same. But topologically, they're related in a deep way.
So does that account for the persistence of kind of like bundles of matter or something? I mean, what kind of it'd be cool to have a kind of real world, if there's such a thing.
Yeah.
A kind of like a dumbed down
Mm-hmm.
version of it.
Yeah.
How does that bear on what we see, right? So matter and the persistence of structure and so on and so forth.
Well, yeah. It indicates that some things can stay the same even when you deform them. There's some in things that remain invariant, we would call it. So you can punch my field and it'll still stay roughly represented by the same invariance, meaning things that stay the same, which is kind of circular the way I'm putting it, but that's basically the core essence of it.
Yeah.
And really, like you're looking at 3D and larger, usually, things in topology, although there's also strings. So roughly you can think of, they're not the same as string theory strings, but basically the circles are string of 1D strings wrapped around the 3D object or beyond. I hope that makes sense. And but you need topology because when you're talking about shapes of this complexity and geometric type, you need topological rules. So if you think of top, it's just like sort of like the surface of things. So it's kind of the study of surfaces and how you can warp them without really changing their fundamental rules.
Yeah, I'm thinking sort of like contours, like you look at a map and you've got,
then you're dealing with topology.
So could we sort of just take a little path towards spiritual stuff? Because you're a Catholic, right? I'm a Catholic. I'm technically a Catholic because I haven't been unbaptized.
There you go. Which means you're saved, right? At some level, but at least you'll go to purgatory or something like that.
But I sort of feel like it's almost everyone I speak to these days has been on some kind of a journey, whether they've either come from sort of like kind of, sort of cold-hearted clockwork Newtonian universe that means nothing. Through some sort of realization, and now they're an idealist, or they've gone the other way, and there seems to be a lot of kind of metaphysical traffic.
So
how does Catholicism sit with being like a cutting edge physicist that's on the brink of discovering unified field theory?
It's funny. Well, I'm struck by the fact that a lot of Western, at least, philosophy originated in the Catholic Church, and because I'm a Westerner, even though I love Eastern religion and philosophy, like I'm mostly exposed to Christianity, right? My grandfather was a Baptist minister, et cetera, and lots of religion on each side of the family. So when I was young, I was taken to Episcopalian Sunday school. I wasn't baptized, so they hand you out the little crackers, and I don't get one, which immediately gives me this feeling like, oh, I'm a heathen and God doesn't love me.
You won't go through the pearly gates now.
Which my mother didn't anticipate. She just thought that you should be of age when you're baptized, which in Catholic you get confirmed at that age rather than baptized. Like you're marked for God, but you don't understand it until you're confirmed, and then you agree with it or whatever. You pledge yourself to it then, I guess.
You don't have to sign. You don't have to sign anything.
Yeah. But okay, so there's that, and then I get this heathen complex, and then by 9, I'm reading Carl Sagan, and I'm reading.
Oh my God, I love Carl Sagan.
Yeah,
he was life-changing. He was life-changing.
Oh, he was great. He's great, and he's a lot wiser and less reductionist than people really give him credit for. I mean, he's the debunker. He wanted hard evidence for anything he really believed in, but like he would write reviews for things like that. There was this woman who had a past life supposedly in Egypt and uncovered all these things about ancient Egypt, and Carl was like, well, if there's reincarnation, this person was reincarnated, I think.
Wow.
And it's like, wow, that's a strong.
Yeah. That's unexpected. I didn't hear about
it.
He
was a lot more open-minded than people give him credit for. Also, like he thought that, just because we don't see a whole overabundance of time travelers doesn't mean the time travel is impossible, because it's quite possible if you're advanced enough to time travel that you're also advanced enough to go through unseen.
Yeah. I mean, in some, just very briefly, Jenny, I mean, in some sense, physics is already magic because it deals in the realm of stuff that we can't see. I mean, the EM spectrum.
We're just looking at effects of things that we don't really know what they are.
Yeah.
What's a field?
I tend to think of physicists and people that work with electricity and magnetism and stuff. They're kind of they're wizards. You guys are wizards, really.
Yeah. And just think. Well, there was a little aphorism I came up with when I was younger. Like a caveman sees thunder and says God, but like a physicist sees God and says lightning, or like exactly lightning, not thunder. A caveman sees God, or sees lightning and says God. And we see God and say lightning, because what's the difference?
Yeah, I mean, Einstein talked about that. He said that there's the kind of the maths, but that's not what breathes fire into the equations.
Right, yeah. Einstein was that. Hawking said something similar too. Like Hawking and Einstein, even though they weren't around at quite the same time, they riff off each other with those quotes. I never know who. Like, is this really Einstein or is this Hawking? And then they were attributing it to Einstein. I don't know. But what breathes fire into it, right? And I don't think the funny thing is that when I saw that the 9D complex Hopf vibration spat all this out, and it's just this beautiful like nested set of circles. So I'm used to people like Lisa Randall saying, well, because it's all discordant, because this field doesn't really combine with that field. When I look at particle physics, like this, to me, this is like proof there's no God because it's such a mess. And I might be misquoting her, but I remember her saying something sort of like this, or someone saying it, but I thought it was Landau. And anyway, and I've heard a lot of physicists say things like that. But when I saw this, it's just this beautiful idea almost that all of these different things fall off of. And I was like, oh my God, there's a God. Which was kind of funny because because ostensibly I believe in God and I try to, but faith is evidence in things not seen. So it's like faith has a sort of agnosticism to it. So I like to say, like, I'm an atheist to certain gods, I don't believe in like Levian Satanism or something like that. I'm atheist to that version. There are other versions that I don't like, but I'm also agnostic to other kinds of gods. At some level, I have a hard time with like a number of things I have a hard time believing in. So like I'm agnostic to other things, but then I do believe in an ordering principle. And I believe that ordering principle and love and various things are very well represented in Christianity. So I can put myself there and I can believe in it at some level.
Yeah.
Even though it's hard.
It's not inconsistent with some of your sort of intuited values.
Yeah. About what matters most.
And I suppose, is there room for some sort of transcendence? Within your system, well, it doesn't bring up the drawbridge against that, does it?
Well, the funny thing is that since every field is sort of a hologram of every other field in my theory, this implies that if you get into a meditative state and if somehow that state is really a good coherent state in your mind, which I think it probably is at some level, then you have your brain quantum coherent, you're experiencing all the fields at once.
Mm.
So you're kind
That's
of, and maybe this is that experience when we feel that universal oneness. Like if you
mm.
take the wrong plants or whatever, you might have this experience. Or if you just wake up and the sunset's especially beautiful and you're drinking an especially good cup of tea and like suddenly like, wow. And then you go down the highway and look at all these people. It's like, they're all me or whatever.
Jenny, I can't believe you mentioned that because there was something I can't I wish I could remember who it was, but I think it was a physicist actually that was saying that do you know that when you go into sort of meditation, I'm no master, don't get me wrong here, but there are those passages where you go without thought and it's kind of fuzzy and it's
Uh-huh. Uh-huh.
vaguely sort of psychedelic and there's some kind of journey going on,
Yeah.
but it's
Yeah.
structured and sort of unrepeatable.
Dzogchen
And,
meditation, man. It's really,
but I think there was some physicists saying that that's what superposition looks like, or quantum
it,
superposition. It's kind
it
of,
is. It is.
you know, it's kind of like all these possibilities are kind of there.
Yeah, and you become exposed to it. You take too much cough syrup, or you eat like yeah. I think that it's quite possible that we are experiencing a coherent state of things, and the reason that you feel
Mm,
one is because you're tapping that level of the field. It's quite possible. I can't prove it,
mm,
but I
mm,
think, but I can prove that like every field is sort of a hologram of every other field at some level. So then
mm,
especially when you get into the coherent fields, because that's the pure field.
mm.
So then,
Sorry, go on.
and you can see that there is coherence in biological systems because that's how photosynthesis works. That's how
Mm,
smell works, actually, because like when you just look at the shapes of molecules, they don't account for different smells because some molecules have very analogous shapes, but they don't have analogous smells. They're totally different, which
mm,
means that like, and it's interesting because smell is the oldest sense. So it's like, hmm, why is this? Uh, I don't know if it's the oldest, but it's one of the oldest, about the same as eyes, maybe it's older. I don't know. But but the eyes are quantum too, because you're getting photons, and then
mm,
you can show that some animals are sensing one photon at a time, which is really weird.
mm. Yeah.
So
Well,
that implies some,
yeah, I mean, well, we construct our realities, don't we? I mean, some fairly
yeah,
sort of high-profile neuroscientists now saying that
yeah,
really, our world is a controlled hallucination. Some of them are
yeah,
suggesting.
yeah, yeah. It is,
But,
isn't it? Well, because we're processing it through our representation of our mind, and then you could say, well, what's to distinguish that from reality? Maybe that's the baseline of reality.
mm,
But
mm,
my reality is probably different than a bat's. I'm not
mm,
I'm not echolocating with sonar, at least not consciously. Apparently, there are some blind people who can do it, which is pretty
mm,
amazing. Like they'll ride a bike and they'll be able to like go hum to themselves, and they'll be able to feel objects around them with that. Pretty
mm,
crazy, but apparently true. And yeah. So, and I think that there are levels of consciousness and abilities that, like like there's proprioception. I'm probably saying that wrong. Where like you sense where you are in space. There's all kinds of sixth senses. Like there's really a lot
mm,
of them.
mm,
But I think that as we evolve, we're going to evolve more, and so we don't know what all is waiting. And also, I
mm.
sometimes worry about the transhumanists. Like if we put a microchip in, we're kind of stabilizing part of our consciousness at a certain level, and then like will we keep evolving and things like that. So
Mm.
augmented humanity. I'm like, yeah, I'm open minded to like using my cell phone all the time to do all these things, but am I open minded to have a cell phone in my brain? Maybe less so. But there are ways that you can integrate with a computer without actually having the computer chip inside you. Like
Mm.
there are wearables and things that will eventually let you like remove the glasses or whatever, so you can benefit from the AI without becoming the AI.
Yeah, I mean, I wonder about AI. Is it just like the plow, that basically you
Oh
won't
yeah,
we won't lose our jobs to AI, but we'll lose our jobs to people that do use AI. Kind of.
yeah, that's what I think. Yeah, yeah, and yeah, exactly. And um yeah, and eventually like we're going to probably move to a more information based economy or whatever, where like
Mm.
we were in the service economy, now we're in the information economy. And then we started with the manufacturing economy, so we're kind of cycling through these economies, and eventually maybe we'll get UBI because like everyone will be just working on these creative projects and making money off of that and being a micro celebrity on Facebook or whatever. Because like the AI will be doing everything, it'll be building things, so we're just going to be having fun. I mean, that's the projection, right? Ever since the 50s, but it never happened.
We'll end up in some sort of decentralized technocracy, I think, where you can like vote online, and there'll just be kind of
Yeah, that
AI
seems
will
really
handle
good.
everything. AI will just handle everything and
Yep,
fix.
yep,
I
yep,
think
yeah. The AI will
it will
vote
fix
because like the AI will
inequality.
the AI will analyze like what your beliefs are, and it'll say, well, you want to vote for this person.
Yeah.
Just file it for you on your behalf. Oh my God. It would be really crazy.
I remember years and years ago, there was a TV series in Britain called Tomorrow's World,
Oh,
and
interesting.
there was one episode where I think it was like 1987 or something. I'm quite old,
Yeah.
right?
Yeah.
And there was this fridge that spoke to you. So it's like you go in and try and get a pie from the fridge, and it says, "Do you really need that?" You know,
You're
and
there.
all this
You're
kind of
really
stuff.
there.
And that's kind of where we are now, isn't it?
Yes,
With,
that's hilarious.
there's some sort of digital representation of ourselves that knows us
Yeah,
better than we know ourselves, kind of thing.
yeah,
Um,
exactly.
but
Crazy.
I mean, have you? I'd love to get your views on some of other thinkers, sort of in the field, and
In
so
physics and philosophy, or
well, the whole thing because I mean, you're
well, it's
tripartite,
funny
aren't you?
because like I've interacted with so many people that like I was on a forum on FQXI, and I'm not claiming any proprietary ownership of ChatGPT, but I remember throwing out there, and Sam Altman was on there, and it was very close to when ChatGPT was formed, and I said like, I think it was a thread about strong AI and whether strong AI is possible, and I was saying
Mm,
strong AI is when you have some kind of material surface that the inside is also its outside and it's
mm,
self-interacting in a certain way. But I
yeah.
said, but the closest thing we could get to that now, because we don't really have the tech to work with that stuff yet, the closest
Mm,
thing would be if you averaged all the words on the internet and all the sentences on the internet and all the grammatical relationships between words, and then you weight them, like how important is a letter, how important is a word, how important is the whole structure of a sentence, and then you like generate different systems and weight different topics and how they relate to other topics, and like you could get this statistical representation of language and how people
mm,
talk, and then you could name a topic and it would start generating. So
mm.
anyway, so I came up with basically the idea for ChatGPT. Probably a lot of other people had been coming up with it around the same time, but it was funny because like I'm on this chat board with all these AI people. So I mean,
Yeah,
feasibly, it's
because
like
haven't you just defined LLMs there?
yeah, I just defined LLMs exactly. So maybe I came up with it. I don't know. I think the idea is older, but
I,
I said it in a really straightforward way, and then suddenly ChatGPT emerges the next
mm.
year.
I mean,
Not ChatGPT, OpenAI, but
my
which
my
developed.
my equivalent of that is far less glamorous. I think I had my ZX Spectrum. I think I was 11 years old, and I thought I want to have a conversation with my computer.
Oh
And so I sort
wow.
of set up. I tried to understand sentence structure and sort of, you have a verb, you have a noun. It was like,
Oh, that's cool. That's cool.
yeah, yeah. And so I
But
could,
that's a proto AI though.
but it was just random. I just used random to generate the words in this structure. But it
Well,
sort of
that's sort of like
sometimes
the
it seemed
Chopra word
okay.
salad, the Chopra word salad generator or whatever.
Yeah, yeah, yeah. And then I kind of realized I thought this is just too hard. Then I tried to do a chess program and that was too hard as well.
Yeah, yeah, I get it. I was trying to do things like that too. There was I was trying to do basic programming, but basic wasn't installed on my computer. Something. It was pretty
Mm.
funny. But yeah, where was I going with this?
Oh yeah, sorry.
No, it's okay. I'm not sure if I was going anywhere. I think you were kind of riffing there, and I was riffing
Yeah,
off
we
you.
were just kind of like we gone into the kind of relationship between Catholicism and mysticism
Oh
and
yeah. So
physics and
yeah, so there are
aren't the
parts
two
of me.
because normally, people, they're not usually on the same side, are they?
No, they're not usually on the same side. And so I was kind of trying to say, like, well, I have things in common with atheists. Like, I have these hard disbeliefs, or anti-theists even. I don't believe in certain things, or I'm
Mm,
opposed to this idea of God because it's just that's my knee-jerk reaction. Then
mm,
there's agnosticism. Like, I'm not sure. I'm open-minded, maybe, but I don't believe necessarily in that. And then
mm,
I have my beliefs, which I believe in order exists and comes out of chaos because you can model that. It just happens inevitably. Like if you look at it like a diffusion limited aggregation, like you get these fractals that come out of just randomly mixing things up, and then they're sticky, so they stick to each other, so that you get this fractal pattern. So there's these beautiful patterns that emerge from just shaking up nuts and bolts or whatever in a jar. So yeah, so order comes out of chaos, which is fascinating. Like, why does it have to do that? I think that there
mm.
was this guy, um,
Does
the guy who wrote
chaos want to be ordered?
yeah, exactly. And so there's this guy, and there's a paper called War of the Weasels, which shows that like randomness kind of generates better stuff than our, at least human intelligence, which is funny. It was a paper. And then where was I going? Heinlein. He's a character in Stranger in a Strange Land says,
Oh my
and I
God,
think,
are you talking about Robert Heinlein?
yeah, it's
The
Robert
science fiction.
Heinlein.
I
Yeah,
mean, oh
I'm
my
saying it
God,
wrong.
because the thing is, I mean, I was, oh my God, I stopped reading fiction for some reason when I was between 12 and 16. All I read
That's
was
about
like
when I stopped,
nature books,
around
and,
17.
and then I went through my mother's entire science fiction collection, and she
Collection.
had
Yeah.
Stranger with a Stranger. I can't believe you mentioned that. And
Yeah,
I
it's a
love,
beautiful book.
yeah, I
And
read
it's
all
like,
of
yeah,
that.
and there's some Christianity in there
Yeah,
sideways.
yeah, yeah.
It's a very interesting book. Uh,
Mm.
but the guy, the mentor of the alien, or the person the alien is mentoring or whatever, the dad or what figure or whatever, he says random chance is not sufficient to explain random chance. The pot cannot hold itself, which I thought was fascinating. I was like, wow, and I highlighted that.
That's really deep, isn't it?
It is really deep, yeah,
Random,
because
hang
like,
on, let me just, random chance isn't sufficient to explain random chance.
yeah, it's such a deep philosophical thought. Like, yeah, so like, and the pot cannot hold itself. It was the next line,
Yeah, because
which I thought
random
was,
chance itself requires some kind of structure, doesn't it? So,
yeah, it
you
does. It
know,
does. Like this randomness, like it requires the card deck and it requires being randomly shuffled, but also just the fact that these permutations of things work the
but
way they
is
do.
that just a fact of being conscious, reflective beings that we can distinguish between such ideas as ordered or chaotic?
Yeah, possibly, possibly,
But
yeah.
then the thing is, we're deeply rooted in the substrate itself. So doesn't that kind
And
of
well,
discourse itself? I mean, that's one of the things I think is the fact that we're here having this conversation.
right,
Got to be
right.
reflective in some way of the
Uh-huh.
substrate from which we've emerged, right?
Right, right. It has to be. So, like, and really, we're just a little localized part of the big thing, right?
Mm,
What's there to separate me from just being this manifestation of the big thing? Like, yeah.
mm.
So we divorce ourselves from nature so artificially. I think it was J.K. Chesterton who said something like, "Well, we talk about nature as if like a drunk who leaves their house and thinks that the house isn't there." I don't remember exactly how he said it, but he's like saying like we think like, "Oh no." We stumble into our living room and we think we've left the house or something.
Mm,
That's how we talk about not being part of nature, like we're artificial or something. I don't know. It's weird how we divorce ourselves. Like we're observers and we're passively observing the
mm.
world, but we're really not. Like we're
Yeah,
a subject of the world, an object of the world, and a subject.
yeah, because physics for a long time seemed to almost sort of get rid of the observer. We were just like a sort of
Right,
like a kind of an
right,
abstract point in
right.
a sort of
Then
geometric
in quantum,
form.
that kind of mangles all that, right? And then the thing that's the most interesting about quantum in some ways is that like I can choose whatever choice. Like if there's super determinism, like it's just all planned from the beginning, which to me is tantamount to belief in God in another way, but whatever. But then, so if I choose a basis with which to measure, which just means like I'm going to measure position or I'm going to measure, um, you know, momentum or whatever, or energy versus time, you know, whatever. Well, although those are not classically
Mm,
observables, but like, so I'm going to measure this thing. Then I make the other thing all go wonky, and it's like that's me interacting with it, and I impact what part of this field is visible, emergently visible, and I make
mm,
the other part of the field go wonky and indeterminate, and that's weird to me. Like,
mm,
and it's weird. So it shows that like maybe we're not determining or creating our reality, but we're dancing with it and creating part of it. We're interacting
mm.
like on a very deep level, on a way that doesn't really quite make classical sense, I guess.
Yeah, I mean, this is, I guess, what I
Like
was.
you're deciding what part of the system is real in the sense that we
Mhm,
intersect with it, which is
mm.
weird. So how
I'm
your
really.
consciousness sets up the experiment, if you believe in consciousness, or it impacts it,
Mm.
your
Well, I mean, a lot
choice.
of people just don't believe in consciousness. They say, well,
I know they don't. That was
it
something
can.
like I said on my Facebook. I said like Happy Halloween because like,
Mm.
uh, and then but on my Happy Halloween was like I guess half of us are zombies anyway. So many people don't believe in qualia anymore. Chalmers was right. But
I
I think
love
like
that. I love that
no,
so much. Yeah, but I
he's
mean,
he's
I
smart.
mean, Dan Dennett didn't think that, you
Yeah,
know,
and then it's like he's an illusionist, kind of like
yeah,
consciousness
yeah,
is an
yeah.
illusion. But
Mm.
I was bothered because he said we're fooling ourselves into believing that we're conscious. Like, where's the self that you're fooling? What's that? Like, I thought you said there wasn't one.
Yeah, yeah, yeah. Well, I had Susan Blackmore, who was an associate of Dan Dennett's on
Oh,
recent.
she's great. She's great.
She's
Yeah.
fantastic, isn't she? And
Yes.
I love
Oh,
her.
yeah. I was listening to your interview of her. I think actually, like, I saw this interview with Susan Blackmore. That must have been your page.
Mm,
She had the
thank
nice purple
you.
hair. The
Yeah, yeah.
pink.
Oh God, I love her hair so
Oh, she's
much.
great. Yeah, but she
Yeah.
upholds the Dennett view better than Dennett, doesn't she?
Well, absolutely, that's right. Because she couldn't understand why he believed in free will. But it was and just she
Oh,
explained
he
why.
did.
It's because he
He
was
believed.
worried. He was worried about a society that didn't believe in free will because he felt that it would
Oh,
be
that's interesting.
damaging. Whereas
That's really
actually, I'm down
that's
with a
great.
Sapolsky. I'm down with a sort of Sapolsky view that you know
Hmm.
that actually the kind of free will that people sort of colloquial free will,
Yeah.
if you like,
Yeah.
people believe in, that doesn't exist. Right.
Yeah.
So life chances are decided by the age of 4 or 5. I mean,
Yeah.
Sapolsky's done loads of work trying to work with, reforming the penal system, and there's
Yeah.
people who are just inevitably going to end up in prison, So I mean, this stuff is actually quite important, isn't it, in terms of how we approach managing ourselves,
Yeah.
you know.
One
Mm.
second. I gotta go and I'll be right back. Like
Yeah, no
a
worries. Yeah,
couple
I'll have
minutes.
a little bio break as well.
Okay. Yeah. Just trying
Yeah,
to
this
figure.
this is fun, Jenny. Thank you
Oh,
so
this
much.
has been great.
This
This
is
has been
freaking
fantastic.
awesome. I love it.
Yes. It really is.
Thank you.
See you right back.
Ah, yes.
I wonder what time it is because we've just been talking and talking. This is great. Oh.
I completely lost track of time, but I
Oh,
tell
me
you,
too.
this reminds me of when I was at well, I've been at a few universities, but
Yeah.
you go out and have a few beers with the physics students, and it's very much like it's kind of like I kind of get it,
Yeah. Yeah. Yeah.
but no,
Oh, this is
I
fantastic. Oh, I
honestly
still have time. This is good.
I live
I
for
still
this
have time.
stuff. Thank you.
Yeah,
Uh,
no problem. Yeah, it's
so
pretty.
this is pretty epic.
Yeah.
What are you up to these days then? So I mean,
Um,
what's a
well, I'm
typical day
still
like for you,
refining.
Jenny?
Oh my gosh. Well, I'm writing my dissertation, which is on
Fine.
explanation and sort of the idea that this relational structuralism that I was kind of describing, where science is basically measure properties and you relate them to other properties. And so this sounds kind of simple, but when you're dealing with philosophers of science, they have all these wild ideas about what explanation is. And one of the views is
Hmm.
kind of old fashioned, is this idea that, well, it's new mechanism, which is the idea that explanation consists of units, which are these entities and activities which get together somehow and
Hmm.
create
Hmm. Oh, you broke up a bit there. You're breaking up.
but mechanisms inevitably always, which impacts this thing, and you can do it. Oh, sorry, can you hear me?
Yeah, you're breaking up for some reason. Is it my end?
Okay. Yeah, I'm in a building, so the building might be. I'll go where I was sitting before and see if that works.
That's
Can
fine. You
you hear me now?
sounds good now. Yeah, yeah, sounds good.
Okay, yeah, it's apparently the part of the building. There's some kind of waveguide that's like creating a Faraday cage.
Whereabouts are you
um,
based, Jenny?
Excuse me?
Whereabouts are you based? Is it
Oh, I'm in
Kansas?
Lawrence, Kansas. I'm here at KU, which is my alma mater for my master's degrees. I'm a PhD candidate here in philosophy of science. I also work with a number of like collectives for education, and
Because
like
you have a master's in physics and philosophy, don't you? Which is
yeah, that's
freaking
correct. That's correct.
that's so cool,
Well, thank you.
isn't
It's
that?
yeah,
Come on.
it's well, it's cool, but it's also because like I was going to do physics, and then my advisor moved to China, and then that kind of. Then I'm like, well, I'll do philosophy. There's all these life decisions kind of play into why I did it the way I did it.
Oh, so you
Also,
didn't
bring
have a well, you kind of did have a grand plan when you were 11, but there's been a few bumps in the road, right?
yeah, but also maybe those things all come together in some way to create the situation I'm in right now. And
Mm.
yeah, so I had a like a there was a health issue, and then there was a Title IX investigation. I took some time off, and that's sort of when TUFT really came into focus because I had this time and I had a thyroid storm, and thyroid storm makes you think really fast. I'm still in some ways like that because thyroid storm means you have really high thyroid hormone, which
Wow.
is the thing that runs your digestion and your metabolism and all kinds of weird clock type related things in your system. So it's
Okay.
sort of like mania in a way, manic
Yeah,
like
so hyperactivity almost. Yeah.
yeah, like it's like ADHD, it can create ADHD like things or
So you can
or
so you can get a lot of work done sometimes.
yeah, exactly. So I got a lot of work done because I was going so fast. And then and I had these like and you know your brain state's unusual, and I had these insights. And so I've had other thyroid episodes that I didn't know were thyroid episodes. I didn't know what was
Oh my
causing it.
God! So have you had flashes of inspiration through these?
Yeah, exactly,
Oh my God,
exactly.
that's kind of like Einstein, Newton. They both reported these sorts of things.
Yeah, these sort of inspirational bursts. And so yeah, I had one that was for me was correlated with a thyroid storm of all things. And which I realized later that like I've been closer to death than I realized. Like people die from
Bloody
thyroid storms.
hell!
Yeah, so I'm
Sorry,
glad that I
I'm sorry,
medicated
really
for it.
sorry to hear that.
Oh
It must
no,
have been
don't be sorry. It's
terrifying.
kind of entertaining in a way. Oh, there we go. I have a Monty Python sort of cheerful absurdist view of things. So whatever. But I mean, on the surface
I
anyway.
kind of get
I was
that
scared. I
always
was
look
very
on the
scared.
bright side of life, yeah?
Yeah, yeah, exactly. And I was very terrified during the episode because I couldn't breathe because my thyroid was so swollen that it was like against my windpipe. I could breathe, but it felt like I couldn't because, and they said that I could have killed me, that I might have lost the ability to breathe.
Bloody hell.
Yeah, yeah, it's weird because like most people when they get a goiter, you see the goiter externally, but mine was growing in, which is why it wasn't caught by doctors earlier. It's crazy.
Wow.
Yeah, it's really crazy.
Wait,
But
sorry,
anyway,
when was that, Jenny?
March this year, and then I got out.
Just recently.
Yeah, and then I got out, and then I had been working on it in 2023, this theory, and I'd done a lot of the basic math, and I said, well, the complex Hopf fibration is the bundle of all bundles, but I meant the U1 bundle. And then I figured these things out, like refined the way I was talking about things, and then I realized that it had to be the complex Hopf, and then after I realized it had to be the complex Hopf, it was easy. Well, David Chester actually said I was working on S7, and he was like, well, you should look at S9 because that's kind of analogous to SO10 and spin operator 10. And so I was like, oh, okay. And so I did that, and then I noticed that like everything kind of fell into place at that point. So so you can get U1 off of the like S7 kind of works, but not exactly. So you can get SU 2 off of the 3D sphere because the kind of it's kind of like a cross section, but it's not exactly a cross section of the bundle. Like if you look at the cross section, you look at all this cut fibers sticking out. That's kind of what the Lie group structure is, but not exactly. But that's kind of an analogy. So you cut the fibers and you look at how the cross section looks. That's sort of like the Lie group. And so the Lie group, which just means this like set theory thing, of SU3, one of them is of SU2, excuse me, is on S3, which is the 3 sphere, which is the 3D surface of the 4 sphere. Which is why, well, no, I won't get there. But then SU3, you can do the same thing on, well, something close. It's actually SU3 over something else, which is, and then the leftover from that division is why you have color, is it either color quarks or flavor quarks or what? There's 5 quarks left over. Well, anyway, that's where it comes from, that division. But so you have SU3 over like, is it SU2? I'm just trying to remember what it was. But anyway, I figured this out, that you can get SU3 off of the 5 sphere. So really, it's complete. The product space for the standard model is complete on S5. But there are these dynamics that you can only really account for if you go to S9. So the fermions, well, the neutrinos are on S9. And maybe that's why they behave so weird. They're a high dimensional thing. So when they intersect with our world, they're doing lots of wonky 9D things. So
I'm
and I
just
haven't.
I'm just browsing through your paper right now, right?
Yeah, so neutrino masses I get off of the Beltrami flow, which is the dynamic field of the static field on S9. So and then gluons are on S7. For a while, it took me time to realize, the fermions have to be on S9 because of the 64 generators or whatever it is. These fermions, I don't think it's actually generators. There's 64 ways they can do certain things, and those are only fit on S9. And I don't remember the way to say that, but I kind of can visualize it, but I don't remember the way to say it. And then S7 is the
we need camera for this on a blackboard.
Yeah, exactly. and then I could like sketch these different things. So then
I'd be totally up for that. You could give us a course on this stuff. I'd freaking love that.
Okay, that
That
sounds
would be
fun.
so much fun
It would be
because
great.
I think we need to understand this, right?
So
I'm going.
so
Can I just ask you? Could I be a bit gossipy?
yeah, sure.
Because in your table of sort of different approaches to
Yeah.
unified field theory, you've included Eric Weinstein with
Yeah,
his,
Eric.
geometric unity.
Yeah. His
Um,
theory is cool, but it still works in a freaking product space. And so he talks about this Hopf bundle and how beautiful it is and all this, but he has bundles, but they're just spaghetti bundles where it's straight, but not cooked spaghetti like the hard spaghetti. So he doesn't
mm,
have actual Hopf vibrations in his theory, which
mm,
I imagine would annoy him if he realized this, but I don't know if he has. Because he always says like the Hopf vibration is the analogy, at least for his theory, but there's no Hopf vibration. So
mm,
I think that he saw some of the basic structure. Now, I don't know who did it first, but my idea was in 2010, and then I had my Vixer paper in 2019, and I think his original white paper was like 2021. So you could argue about who was thinking about the Hopf vibration first, but at least I had the actual structure. So,
mm.
but he's very, he thinks deeply about things. Then there's Garrett Lisi, but he's just working with Lie groups, which means that you are just dealing with the product space again, usually. And the way he does the E8 group, like that's basically that.
Could you
But you
give
can
us?
think of E8 as sort of an overlap. You can build E8 on S9. So
Okay.
it might not be completely useless. I just think that Lisi had the gall to call his 250, whatever it is, it's 250 some dimension theory exceptionally simple.
Mm.
Like mine is like 9D or whatever, and you get basically, so it was funny to me. Like, so that was one of my frustrations, was that all these theories looked really kind of, well, a lot of them look like you're trying to glue different things together without an understanding of how they connect, and
Mm.
topology allows you to connect them. The other thing is that like they were very needlessly, in my opinion, complex. Now maybe I'm just stupid and like these people can conceptualize all these things, but I don't really think so. I think I'm just efficient, and I didn't want to have to do that. I thought
Mm.
that reality should be simpler. And so like the thing is, like, really the universe is just this yarn ball in my theory, so it's kind of an easier to visualize thing than a lot of what everyone else is doing.
Mm.
And then and I don't really, even though my
So
bundle is
so your system eliminates singularities.
yeah.
That's mental. I mean, that's
It's because
how do you do that? Because
because it's,
Einstein accidentally gave us some singularities, and
you know what was really funny is that Einstein and Heinz Hopf, it's like God was trying to put them together. They only worked like 5 doors down at ETH0. So they could have gotten together, and Einstein could have, and Einstein even worked with Heinz Hopf's cousin, who did the statistical
You're kidding
work.
me.
Yeah,
There was
he
just an
worked.
accident, a sort of sociological accident that.
Yes, he never really. I don't know if they thought, oh, they're weird, or they avoided each other, or what exactly. But Einstein corresponds with like everyone at ETH Zurich except Heinz Hopf,
I
which is
can't
great.
believe.
Yeah. But Einstein kind of,
Could have
he
saved
liked
us so
different.
much trouble.
Yeah. Well, I think Einstein too had just learned his manifold metric theory, and like looking at these bundles would probably have been a pain in the neck. But if they had collaborated, they might have had something like TUFT. Like they wouldn't have the standard model in it, but they might have figured out an analogy for
How
fields
do
of
you
quantum mechanics.
how so I mean, if it's possible to explain it to someone like me, how do
Mm-hmm.
you eliminate singularities via topology? Theorem 7, apparently this is.
Well, basically, like singularities become uh, like, okay, I'm trying to think of how to say this. Like, so the singularity goes to infinity, which means that we don't have the math to describe it in GR. But in my theory, you can look at the braiding of the fibers, and from there, you can get a smooth picture of what the deformation of the black hole looks like. So you still might have wormholes, for example. In fact, you do, because of the base space is basically a wormhole, R equals EPR space. So entanglement and wormholes are roughly the same. Not quite, but in the same connection space. So, and then black holes are just kind of like dips in this thing that don't become a full wormhole, and you can describe it, and then it's self-consistent, and so it's
So
because
it's not an infinite It's not.
It doesn't go to infinity anymore. I mean, it does in the sense that it doesn't, like, it does in one sense, like if you in this math that goes to infinity, but it, like if you're in that map, it's like infinity because you don't understand it. But then you go into this map, and you can.
So does that
Which
mean
is weird.
would you can I
It's not
ask
that I don't believe in infinity.
what are black holes then in your view of things?
Really strong gravitational lensing, basically, like a deformed structure, but it deforms the field to such a deep degree that it's like a singularity, even though you can. It's like the black hole picture, except that you can map it, and you know what's going on, and probably it solves the information paradox too. But I haven't really dug deep on that.
But this reminds me, actually, didn't you do so? Aren't you're an expert on gravitational? Sorry, no. The structure of yeah, galaxies
Oh
and
yeah,
stuff.
I'm
Yeah,
originally a
you've got a
galaxy.
background in astrophysics as well, haven't you?
Yeah. My mentor, Keith Ashman, was a astrophysicist, and so I kept doing work in astrophysics for quite some time. He was
Yeah.
a galaxy physicist too.
So you can explain sort of galactic geography almost.
A little bit, yeah. And what's interesting is you can now kind of solve the problems that oh my God, where Vera Lind and other people were looking at that had us come up with dark matter. You can kind of solve these problems by looking at the torsion and the holonomy, meaning the twist of the fibers. The twist and the torsion are kind of analogous to one another in my theory, but like, so you look at the holonomy and you get dark energy. Look at the torsion and you get dark matter.
It's just to do with the landscape problem.
Yeah, I solved the landscape problem.
Yeah.
Because there's only one structure, and the structure has all these different properties that just fall off of it. So string theory, the problem is that it's this kind of cute math that will do a unification feasibly. You can see that there's a possibility, but because you're on a Calabi-Yau, excuse me, you're on a Calabi-Yau space. The Calabi-Yau space is not computable in the standard sense. So you get all these. It's all, kind of like the singularity. You just get all these infinite numbers of ways of looking at it because it's not easily computable.
So I mean, what is gravity for you then? Is
Oh,
gravity?
it's torsion. It's rooted in
So are you
twists of the
actually we did
fibers.
touch on this. So it's torsion within that topological structure.
Yeah, there's torsion, which is just
What
basically.
is torsion? Can we just
Oh, torsion. What is torsion? It's sort of like torque. If you think about torque, it's sort of like that, but it's like whirlpools have torsion, for example. If I spin around, I have torsion. Torsion is just the twist, the helicity, like the pinwheeling of stuff.
Okay.
And then what happens because of the pinwheeling of stuff. That's torsion.
Which way does it go? You talked about chirality earlier.
Oh my God. I can't remember which way. It's either right, which causes it to be left, or it's left that causes it to be right, or maybe it's this. I don't remember. But the funny thing is that, like, this is also where chirality of molecules comes from and things like that. And you can also use this to explain a lot of things about the periodic table that looked weird before. And that's
right.
Yeah.
So there's kind of like a pointer to sort of chemistry here and sort of okay.
Yeah.
So you can count for some what
Chemical
can you
issues, yeah, and maybe some biological issues, although that's getting more emergent, I guess. It's chemistry, yeah. You can count.
I was going to ask you about that actually, just really, really briefly. I was going to ask you, is there just one science, and is that science physics?
Yeah, I really think that it's all physics. Yeah, it really is ultimately all physics. And I know people. I know people.
But what about math? I mean, could we then go further and say actually it's all math? Because
Yeah,
you always. I mean, Mike Levin made this point the other day. He said sort of wherever you go in physics, you always end up in the maths department. They say there's some mathematical structure.
Yeah,
It's beneath this, and you're obviously. I mean, obviously you describe these phenomena with mathematics, but
yeah.
you know. It all sort of seems to end up with maths, right? And is there no other way of doing it, is there?
The language of physics is math. And originally we were applied math, which originally was logic and natural philosophy, which is kind of funny. So it kind of, like, I think Sabine Hossenfelder said that, like, really it all goes back to philosophy, which is math, which is physics, So yeah, it's weird to think about. Like, so it all comes down to ways we are organizing our thoughts, right? Quantitatively and qualitatively. So you can organize qualitative thoughts and you end up with sets and proofs, which is a kind of math. But I hope this is making sense.
Of course it is. This is fantastic.
So yeah, so there's this. So my handle on Twitter is Qualia Quanta, and that was kind of a riff on the fact that, like, these things are interrelated but don't reduce to each other exactly.
That's what I wanted to ask you actually. So,
Mhm.
I mean, obviously with physics, you get this. I mean, if you look at the history of physics, you start with earth, air, fire, and water, right?
Yeah.
And then you end up
Right.
with sort of Newtonian stuff, and then you end
Uh-huh.
up with relativity. And
Mhm.
I mean, it seems that I mean, presumably quantum theory will be superseded by something, right?
Yeah, I think it's
No?
actually superseded by what I've got. Because my thing really shifts quantum very slightly. So in some ways the system is more deterministic, but then you see the randomness pop out even more.
Mm. But
Uh,
then you're,
more
but aren't you using some of the mechanics? You're using some of the concepts of quantum physics
yeah,
in
but
your.
the thing is that I started with like what would combine quantum and GR really. And like Weinstein will yell at you and say it's really the standard model in GR, but I thought about it the opposite way. I thought quantum and GR was the way to go, and then which I think was for me it was right. It worked, and then I thought of the standard model later
Mm,
because I was thinking about what the Hilbert space would look like when you combine it with GR and you combine it with the concept of trajectory. Like so, I was thinking about like what would this look like, and that was sort of how
mm,
I ended up here. Um, like what's the wave function of the universe look like?
mm.
Um, so that, but where was I going with this? Oh, but the thing is that TUFT is a slight modification, slight, of all these different theories, which is why I have a phase prediction that you can't get from general relativity, even though it's if you take an accelerated light beam, there's all these different things that GR predicts, but I predict a different kind of wobble in that light beam, an oscillation that isn't there in GR or quantum. Then also I predict the particle masses, which you can't get just off of the generalization of quantum theory to standard model quantum field theory.
And have you tested these predictions?
Well, I haven't tested the neutrino masses yet because we haven't measured them. But that's coming up in probably 2026 to 2028 sometime we'll have them. And then
Wow.
if that comes out like my theory, then that
And
would be
maybe
very
you could take us on a tour of what it means. I mean, how can that be proven? So what's involved in showing
well,
that's the case?
people have to look at the math of my theory and make sure that's consistent. People have to agree that my math predicts what I say, right?
So
And
the internal sort of coherence of it, sort of.
right. And so my paper is under peer review, and I was shocked. I don't know if I'm supposed to be saying this about peer review, but whatever. I was shocked when I opened up my report, and both reviewer one and reviewer two said that my work supports my conclusions. And for a UFT, that's just totally insane, the dream. Like what? You couldn't be serious. And then one of them, like I think I know who they are, but whatever. One of them said like the Gaussian rise. Look at the Gaussian rise a little bit. And so I poked at it and like I found that like the way I was getting torsion was really off of a generalization, like a local version of the rise. But there's this universal thing called rise that I could look at, and that thing made the particle masses come in much more smoothly because before I'd had a little bit of wriggle and I was like, why isn't that matching the experimental mass when this did or whatever? And then when I plugged in right, it's because I was doing a numerical calculation off of a thing that was more standard. But it was cool that my reviewer pointed that out that I could do that. And like I had already kind of done it, but I hadn't done it in that particular way, so it was cool. So they made suggestions like, look at this, look at the rise, look at this, and then see what happens. Look at dark matter, look at dark energy. So basically, they asked me to expand my scope and also think about because I'm sure I have a topologist on there, and so wanted me to look at
Mm.
different aspects of the topology,
Can
which
I
was
ask
great.
you what, I mean, did you by any chance, I mean, I asked earlier if I could get a bit gossipy. So
Yeah.
Sean Carroll and,
Oh, Sean's
and
great.
and Eric Weinstein kind of they don't like it. They don't seem to sort of agree with each other and sort of
Well, I think maybe I think a lot of people get. Oh yeah, that was funny. I honestly think
Carol thinks Eric's a bit of a nutter, doesn't he?
yeah. Well, there are some issues with Shiab operators in Weinstein's Lagrangian and things like that. But what was crazy to me and what was unfair to Weinstein was that Sean was saying there wasn't a Lagrangian, and there was. What I think Sean did is I think that he'd heard other people talking about Weinstein and what was wrong with it.
Yeah,
And
yeah.
then he probably took something like Adobe that was summarizing it, and then his subscription ran out.
So, no, Adobe would have been okay. ChatGPT would have failed.
Yeah. Whatever. He ran out of tokens or whatever. So it's like,
Yeah.
like
So do you think he was unfair to Eric?
he was unfair. I do think that there are ways, like Weinstein's working on a product space. It doesn't have twist. It doesn't have a Hopf vibration. Those are ways to kind of dig at him because he claims there's something important about the Hopf vibration, yet his math doesn't really produce one. It produces these straight bundles instead, like uncooked spaghetti, whereas I deal with cooked spaghetti. so those are ways you can kind of dig at him. And then there's issues with the Shiab operators that I don't really deal with, so I don't really know exactly what those are, but I believe someone that's probably something to it. And maybe Weinstein has a counter, I don't know. But but I think Carroll had an intuitive thing that he tried too hard to say straightforwardly, and it's like, no, there's
also, Sean Carroll believes that the world is a wave function, doesn't he?
And I believe he has kind of a smooth concept of the universe. I could be wrong there, but I think he's like, we're thinking about continuum. And I think maybe Weinstein, even though he does sort of deal with the continuum, he might be, well, I don't want to project onto him, but like there's these sort of knee-jerk intuitions that each guy has, that don't quite agree with one another. And that's where and then you put them together and they haven't really looked at each other's work very well. And then suddenly it becomes this animosity. But what was weird what was unfair was that Weinstein came up with a successful quip back at Carl, and then the news agency or whatever that put up that interview, I don't remember who exactly did it, kind of clip that out because they liked Carroll better, but Carroll was wrong. There is a Lagrangian. Now the question is that Lagrangian okay? Maybe not. Like, is that Lagrangian? And his Lagrangian is depicted in a very odd, he has this like map of like this variable goes to that variable, and like I kind of figured out what it was looking at it one day, but it's not standard notation. It's probably more like what mathematicians use, but physicists look at that and they're like, what the heck is he doing?
So is that something to do with the tension between, mathematicians and physicists then? I mean,
the way physicists and mathematicians do things is different. And what mathematicians consider important when they're looking at a structure versus what a physicist considers important is different. And so I think Weinstein also makes that, like when you read his paper, he doesn't have a lot of words about what everything means. I mean, he has an introduction, he has a conclusion, but then as you go, he doesn't really explain what his variables are.
But then he's trying to solve a very specific problem, isn't he? And so is it to assume that the people who are going to read that paper are probably got to be acquainted with those those fineries?
That's a mistake, because like, say for example, if I wanted someone who works in Lie groups, like Garrett Lacey, he has a theory of everything, kind of. There are flaws with it, but he has a theory. So he's a theory of everything guy. He should be able to read my paper and understand it, right? Well, I don't know. Garrett works with bundles a little bit, but he mostly works with Lie groups. Maybe I'm not projecting anything onto Garrett personally, but just like people who work in Lie groups, they might not know much about non-manifold topology, because like something more complex than a sheet, if that makes sense. So like, if I'm dealing with something more complicated
non-manifold, I mean, could we just non-manifold topology?
Well, I mean, like,
how can you have a topology without manifold?
Well, you have the manifold, but then there's an additional factor, which would be the twist of the manifold. So it's kind of a manifold, but then it becomes a bundle because it becomes a certain kind of bundle, a non-trivial bundle, because you have twist. The trivial bundle is like spaghetti, remember, it's just straight. But and that's just kind of more like an analogy to a manifold. But then if you add twist, then you get this non-trivial bundle thing. And then you have to go beyond just the Lie groups, because these twisty things have Lie groups, but Lie groups do not have the twist. So that's why, like, because Aharonov-Bohm, I might be saying that wrong, I don't know, or these other people, or charge quantization, these things require some degree of twist. So that means that, like, when we're just dealing with Lie groups, we're not seeing it. So we're just dealing with a cross section of the picture analogously, not the whole thing. And it's not like, it's very close to a cross section, but it's not exactly. But I don't just think of it like that.
I'm reading your paper now. Sorry.
Oh my, that's fine. That's fine. Yeah, it's one. I think the part on complex time is understandable, I hope, to lay audiences, and I think some of it, and I try to introduce the fiber bundle structure and define a bundle and define isomorphic and all the, or isometric, all these things, and so that the motive for that was so that Jack, the original motive was so that Jack could understand, Jack Sarfati. He wanted to understand it, and so I finally came up with a way of talking about it with these nested bundles. Also, the ping pong ball, I never explained what the ping pong ball that the yarn is wrapped around is. So S3, S5, S7, S9, those are the yarn balls. But the ping pong ball at the center is the connection space. And so the even numbered dimensions are those things. So you get S1, S3, S5, S7, the odd numbers, and then the even numbers 2, 3, 2, 4, I'm obviously my arithmetic sucks, but so the even numbers, they're the connector spaces, and they're even.
Topological theory, structure, and dimensionality. I've just got to 9-dimensional complex Hopf vibration.
Yeah. So the complex Hopf vibration means that you have a Hopf vibration, which is this twist, like this bunch of circles wrapped around a ping pong ball, essentially. And then those are twisty circles, which is weird to think about, but like you can imagine them as Mobius strips. They're not quite the same as a Mobius, but
so is there is there some, so these structures that you're describing, is there evidence of is there empirical data that supports the existence of these structures?
Well, the fact that you can pull the particle masses, like I can calculate what the electron should be, what their mass should be. I can calculate what the quark masses should be, which are really itty bitty, and I can get those. And I can tell you about where the color quarks versus the flavor quarks come from, and things like that, or the top versus, So because you can find those things off of it, that has some like bearing on the fact that, well, if I can use this thing to get these things, it's probably real. But then you have the problem of epicycles. So in the like the early modern, like late medieval, early modern era, they use these epicycles. And I mean, actually, they really go back to Ptolemy, so they're even earlier than that, really early astronomy. And epicycles were a way of viewing the Earth is going around the sun, but still getting the right math. I mean, excuse me, the sun going around the Earth, but still getting the right math. And so you could have a theory of epicycles, but the thing is, epicycles are slightly off. So even when you're looking at the math, it's not quite right. So if you get a theory that produces values that are very, very good, like with an experimental error, then you're thinking, well, this is a model that works. And then if it's a model that works, you can think like, well, this is what reality is like, kind of. So, but one thing you can see is that the gauge structure of the Hopf vibration represents things about fields, represents things about the strong nuclear force, represents things about things that we measure. Again, so, and we've known that it's kind of a way of viewing the electromagnetic field, etc., for a while, but like people don't usually use it because it's a weird thing. And the traditional representation of fields, like from Maxwell, is just easier to wrap your mind around.
So what sort of what could happen if your TUFT is true?
Well, there are a number of things that.
What are the implications? Yeah, technology-wise.
Well, time might be more malleable than we think. So you might be able to travel a little bit in time, back and forth, which would be weird. I don't know how. Like, I assume it would take more energy to go further back, or more energy to go further.
Because we can a bit already with Einstein, can't we? We can get on a Boeing.
Yeah, you could. It allows time travel.
Yeah,
Einstein. But mine might allow navigable time travel, where you can tune something to make it go to a specific place, which is weird. And also, because of the math off of TUFT, I was able to think of a way to solve Navier-Stokes that's not been done before, which was by putting it in the complex time of a Hopf vibration. And then if you use double Hopf with statistical Hopf as well, the other guy, the cousin, if you put all that together, you get a really nice picture of Navier-Stokes. But I can also prove, or rather my fiance gave me the idea of how to prove, and we worked together on this, that the Navier-Stokes equations are incommensurable in, not compatible with real time, which implies that there's this element of the field that is complex to begin with, or the element of reality that's in complex time, which is cool. So time has to be complex, which just means it has an imaginary component and a regular component.
One of my sort of daft philosopher questions was going to
Yeah.
be, what do you make of time? And
Well, I
I
think
was,
time.
yeah, I mean,
I,
sort of Maudlin seems to go for a sort of he thinks the common person on the street has a better conception of time than most physicists.
Probably true.
But
Well, I think of okay. So here's the deal. I think of all time that's ever happened, or that might have happened, or that could have happened, or could happen. I think of all of these things as existing at once, which is kind of the
wow.
Einstein view. And the reason is because, like, since we have these pictures where this happens before that, or that happens before this, because like you can change the time ordering. That
Mm.
implies that those things are going at the same, like that those things, since you can rearrange them in time, but they're the same picture, that sort of implies that like both of those versions exist at once, which implies that like all of time. And then Gödel kind of did some work on this too. Gödel, however you say it.
So why does it seem like time has a direction then?
Because we're being pushed through that picture. We're being pushed through by the twist of the bundle, really.
So pushed
It's
by a
the
physical.
torsion. The torsion twist is like pushing us further and further down the string, which eventually loops in a certain way, but not exactly a perfect loop.
Mm.
Mm-hmm. That sort of help. Like so, basically, like there's a force that's sort of pushing us forward in time.
So we are pushed from behind. We're not pulled
Yeah.
from the
Well,
front. There's no
it's
special
both.
attractor. There's no some
It's
sort of
we're
ideal
pushed and
object at the end
pulled.
of time.
Yeah, we're sort of pushed and pulled. It's sort of the same thing because it's like it's a circle. So you're being
Pushed up,
pushed and you're
right.
being pulled. Yeah, and so like so that is like you see the whole film, but we're like, have you seen Donnie Darko? He would see
Oh
people's like.
God, yeah, yeah, yeah,
I
yeah.
loved it. I loved it.
Oh,
Yeah.
what a
So
great film. I forgot
it
about
was a
that.
fantastic film. It
I
was
forgot
fantastic.
about that.
Yeah, but he sees people's world lines. So presumably the whole world line exists, but our consciousness, which is like our classical embodied part, is just being shoved through there because of, or shoved or pushed, pulled, whatever, along this thing, because it's not really pushed or pulled. It's more like we're being dragged by a
Hmm.
tidal force, sort of.
But what accounts for the fact that we have these kind of unique perspectives? I mean, why am I me and not you?
Oh well, it's a good point. Well, because probably because of the interference pattern. Because certain things, like certain part, like why are particles distinct from one another? And then
Mhm.
once you know why particles are distinct from one another, and then you make a collective field out of all these particles, then somehow this thing is separate from that thing, even though they're really part of the one big field. They seem distinct because of the interference.
Mm.
Like it isolates little ball. It's like sort of like water droplets or like things that splash and or ferrofluids, and these little pieces come off and then come back in. And maybe when we die, we go back into the big field and then we rearrange into
Mm.
another.
Yeah,
There's
like a sort
structure.
of a little sort of globule of liquid returning to the main
Yeah,
body.
yeah, yeah,
Yeah, yeah.
yeah.
So I
It's
mean
weird.
that sounds like well, you mentioned the Upanishads, a couple of hours ago now, because
Mhm.
we've been at this a couple of hours.
Yeah, it's
Um,
amazing.
and that offers up a sort of idealist
Yeah, there's an element of
metaphysics, doesn't it?
idealism. I think that if you go far enough into logical part of positivism, that you come out at idealism. So you find that
Really?
the most, yeah,
I mean that that doesn't I mean that sounds crazy because in a way the logical positivists will say
but you
no, let's
see, like you were talking about,
wipe all the metaphysical questions off the table. And you're
right? But
saying that
then, but then
actually it
they
leads
become
to
louder
ideal.
and
You're saying
louder.
it leads to idealism.
Yes, because they become louder and louder the more you refuse to look at them. Suddenly, like it's like, what is all? If I only talk about it this way, like most of reality is missing. So it kind of
Yeah,
blows it
yeah,
into
yeah.
this.
The reality that we can actually relate to is not
Yeah.
there.
Or like where is the Buddha nature found? Nowhere. Or or sort of dog poo in the grass,
Mm,
or whatever the answer is with the koan, depending on your teacher. But
mm,
like like so that there's the tradition of that koan where you don't, like, there is no Buddha nature, and then you giggle,
mm,
and then you kind of feel the Buddha nature when you say that. That's called via negativa in the Catholic tradition. So
mm.
via negativa is the idea that you talk about what God is not. And you keep talking about it, and you keep talking about it until what it is sort of comes into the negative space of the negative. And I think that that's
Mm.
why so
Maybe
many
that's
people,
dark matter. That's dark matter, isn't it?
yeah, 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 yeah. It's sort of like you just go so far into it that what isn't there becomes apparent to you as a negative image of that,
Mm.
the
Oh
absent.
my God.
Yeah.
The non-X.
The non-non becomes a
The
thing.
not the non-X. Yeah,
Yeah. It's weird. It's wild. So I think that that's why you see a lot of people who have a journey, like M. Scott Peck talked about, like how everyone is an atheist for a while if you're on this journey, and then you see God eventually in your atheist phase. So I was an atheist when I was 9. When I was 9 years old, I was like, my mom. I'd go on my back porch. I'm like, God, show up. And God didn't show up, he didn't talk to me. So I'm going to my mom and I'm like, there's no God. I'm an atheist now. And she's like, that's nice, dear. She's a very strong believer, but she's just like, there's nice
That's
people who don't
nice,
believe
dear.
it's okay. It's just, I believe in God. I think he'll come around, but just really nice and accepting, which was funny because like she comes from this very religious family, so it was really funny. But I
Be
think
back
it
next
related
week as
that
a pantheist or something.
yeah. So then, but the thing is, like, I think back to that, and like, it was a beautiful evening, right? And I'm drinking my iced tea, and the cat's in my lap, and I'm looking at the sunset or whatever. Like, maybe
Aw.
God was there after all, right? Like, or at least some manifestation of God's creation or whatever. And then I think there was another theologian who said that like atheists love God the most because they're so happy with his creation that they don't need anything else. Which I don't know.
I've never heard that. That's beautiful.
It is beautiful, isn't it? It is beautiful. So, like, I think that these views are often inverse views or polar, like the polar opposite is kind of contained in the mirror image.
So in the same paragraph, you said that idealism emerges from logical positivism. And that's fantastic.
Yeah.
That's
I think
beautiful.
and also, if you say everything that exists is just the stuff I can measure, then then panpsychism is just the kind of the opposite of that, right? Well, because everything is mind, or everything is just what we can, like mind is just what we can measure, and everything is what we can measure. So like, there's it's not quite equivalent, but there's a certain overlap where you're like, oh, what's the difference between all is material or all is mind?
Yeah. Have you come across Mike Levin's work at all?
Not a lot. You should talk to me about it.
I mean, I know it's biology, so it's a whole different discipline.
Oh, a little bit, yeah, a little bit.
But he has his own lab. He's well funded. He
Yeah.
does. I mean, he's a developmental biologist with peer-reviewed work and all this kind of stuff.
Yeah.
Highly reputable. But he's
Yeah.
now coming out and basically saying that he thinks that biology is some kind of ingression of Platonic forms and stuff like that.
Which
So
is pretty
he
wild,
kind
right?
of almost it's fucking wild stuff, but he thinks he has lab results. Excuse my language. He thinks he
It's
has
okay.
results that actually back some of this up.
Well, that's really, yeah. And I kind of looked at it a little bit, but my mom got me this book. I talk about my mom a lot, called The Beginner's Guide to Constructing the Universe. And it was just basically all the Platonic. It was basically all these Platonic forms, but you can see like when you're looking at these like flower of life and things like that, you can see analogies, or the basic of Pisces. You can see these analogies for cell division and things like that in the shape.
And
So
things
it's
like Fibonacci sequences and things. Yeah.
So my brain is a manifold, right? It's a twisted manifold, really, actually. So you can think of it as a waveguide for a field, that is twisted. But where was I going here? That
Biology,
kind of
Mike
implies
Levin.
that these biological things are instantiations of mathematical forms, right? Just because the fact they take mathematical form. So you can say like that as like, oh, well, because my brain is shaped this way, my brain behaves certain ways, but that doesn't really mean that math is real in some way. But then you could think about, but there's so many different things that have the same shape, but slightly different form, but the same shape. Like that implies that there's something common to all of them, right? And this gets into the whole Abelard versus I forget the other guy, which was about sort of Bernard, but there were other people who were more mathematical arguers about whether universals exist. So then you go into like, was math a name or is math a thing that has a name? And then, so it's complicated. And I don't know if you can actually represent a universal, but there's an implication that maybe there is something genuinely universally applicable in these equations that you can put in different places. Maybe. But yeah, you can go on and on and on and on. Do you want to talk again on video? I need to get on pretty soon, but this has been great. This has been great.
This has been really good fun, Jenny. I've got to crack on, to be honest, because I'm getting tired.
Me too. Me too.
We went,
I need to do.
we went for a big walk in the forest earlier, and it was just
Yeah, it's like
we
risk.
lost the car, and the phones weren't working. It took us about an hour, 2 hours to get back to the car.
Yes,
So
exactly.
I'm actually physically exhausted.
Well, some people say, and I don't know if it's true, that you burn more calories thinking hard than you
Oh
do.
my God, yeah, that's so true because I'm really into chess, and
Hmm.
so the English champion Nigel Shaw, he played Gary Kasparov years and years ago.
Oh,
It was
that's
the
fun. That's fun.
it was the worst televised sports event ever because they weren't even
Yes.
most of the time they weren't even on the stage, you know.
Yeah.
But
Yeah.
he lost I think he lost 3 stone over
Oh,
that
wow.
court. Yeah, and that's just
Wow. That's
the
amazing.
brain chews up more calories than anything.
Yeah. Yeah. Well, it uses the most sugar, which is the purest
Yeah,
form of
yeah.
calories, right?
I don't
It's
understand
amazing.
why I'm still so chubby, but
Well, you're eating enough to keep up with it, I guess, which isn't a bad thing, right? You survive.
oh my God, Jenny, we've just been chatting for 2 hours. I mean, I can't say that I understood all of it, but
Well,
I think I'm kind of get some of it.
yeah.
And also
Read
you,
my Medium article. I have two Medium articles. One on the product space, which is how you sort of need a little math background to understand all of it, but you get it basically. And then I have
mm,
another Medium article, which is about the yarn ball model,
mm, the
and
yarn
it's
ball.
yeah,
Yeah.
which is sort of the Hopf thing.
Mm.
So yeah, it might help, might make it worse. I don't know.
Could you send me some of that stuff? And it's so cool that we managed to just hook up through Facebook as well.
Okay, yeah, it's
I
amazing.
love
Yeah,
that.
Facebook is a beautiful thing in some ways.
I think it
Sometimes,
is. I think it
yeah,
is. A lot of people kind of, oh, Facebook, this, that, and the other. But I think no,
you just have to take
it's a
control
village
over your.
notice board, and it's up to us how we define our village. You know.
Exactly, exactly. And there are ways to manipulate your feed. Like if you don't like something, try not to click on it. That's very hard for me. So my usual reset button is I go and I like a lot of cat pictures or tiger pictures or nature videos, and then my feed is suddenly all that or all art or whatever. And then you can redirect your feed around those things, and you get better and you get better friend Rex too when you do things like that. So try to create a positive attractor instead of a negative attractor. All right, this has
Absolutely.
been fantastic, Matt. Thank you so much.
Really? Have you enjoyed? I'm so glad you've enjoyed.
Oh,
I've
I've
really
enjoyed it a
enjoyed this,
lot.
Jenny.
It's been a lot of
You're
fun.
so
Like
much fun.
obviously,
You're so
you have a
cool.
good mind that can understand a lot of things. So it's good. It's fun to talk to people who get things. So yeah, and
I do my
I
best.
try to make it such that anyone can get it, but that can be sometimes like if people come from too different a space of like if I'm talking to a sculptor, I have to have sculpture analogies or whatever. And so but you obviously like this stuff, so I can riff with you and you kind of get
Mm.
it, which is
Yeah,
great.
yeah, yeah. I
Hmm.
really do want to understand.
Yeah, which is
But
fantastic.
no,
Yeah, and obviously you have the capacity.
and
So thank you.
I sense there's a hell of a lot more to discuss as well in the realms of maths and philosophy. We didn't even touch on AI, you know.
Yeah. Oh, yeah.
So
AI is a good thing to talk about too because
yeah.
it's everywhere now.
But
Yeah.
we should do it again with camera and be great to see you. But
Yeah.
I think I might mix some of this down and I'll send you something and see if you like it. And if you do, then
You can do whatever you want with it as long as it's like legitimately what I said and not some like deep fake. But
I don't think I'm smart enough to replace anything that you've said, Jenny.
yeah. Yep. 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 That's great.
But
That's great.
I thank you for your patience and thank you for putting up with the daft questions. And you're in some. I still see physics as magic. I really
It
do.
is. It is.
You're
But
the
let's be
alchemist of the modern age, and
honest. Oh, thank you.
you're a gift. So thank you so much.
Thank you too. You are too. Thank you so much. Mutual love fest.
Um,
Have a good one. Okay. Take care.
take care, Jenny. Speak
Yeah.
soon. Bye.